Okay, good afternoon, everybody. I think we should start our mini symposium. My name is Raman Pranjape. I'm the Associate Dean for Research and Graduate Studies in the Faculty of Engineering. I want to begin by doing our land acknowledgement. Our university is situated on treaty lands. These are the traditional homelands of the Nihi Awa, the Anasenepek, the Dakota, the Lakota, and the Métis Nation. Our time on this land is temporary, and it is our responsibility and our duty to take care of and protect this land. We hope that these lands will continue to be the home of many diverse people who will continue to take care of and protect this land. So I'm really very happy to see you all here. I think that what we are doing today is a very, very important activity. I very much appreciate you coming against all odds and our never-ending Saskatchewan winter, but we are here, and that is really, really good. What we are discussing in this symposium series is going to have far-reaching impacts upon our lives, and most importantly, the lives of our children and their children going forward. Today's symposium is focused on the built-up environment. But this is the first of a series of symposiums that we are organizing, which will cover other very important areas, including transportation, industrial activity, and energy. Those are the four that we have currently planned, but there may be more after that. We believe that these symposia are going to actually pose more questions than they're going to answer. But we believe that we are beginning a process through which we will move closer, a little closer, to where we need to be in order to get a world which does not emit greenhouse gases the way we have been emitting in the past. So it's my intention that what we will do after these symposia, or after each symposia, is we will actually create focus groups. And it'll be open to anyone that wants to be part of that focus group. And what we will do is we will have that focus group summarize what we talked about in these symposiums, as well as create sort of a repository of information that will be available on each of these topics, with the idea that, you know, anyone who has questions or wants to find answers, if we have those answers, well, there'll be a place for them to go and to sort of hopefully start to find solutions for them. So let me just finally share sort of my perspective on this problem. So the way I see what we're talking about in this series is that we have a particular way in which our world has been operating. And that way has included producing large amounts of greenhouse gas. And we need to transform that world into a world in which we are operating in a carbon neutral kind of a way. So the question really comes down to, how do we go from the world we're in to that world that we want to be in without frankly bankrupting ourselves or creating, you know, great social upheaval, which, you know, would be one way to go. So in my view, what we're really talking about is a new kind of engineering. And I've picked a name for that new kind of engineering. I guess what I think is I would like to call it transformation engineering, because we need to transform our world from where we are to where we know we want to be. So with that as sort of an introduction, I want to say that we are recording this presentation, or this series of presentations. We will ask our speakers to actually speak for about 20 minutes, and then there'll be about 10 minutes for questions. We'll have a short break at around 3:10 for you know, sort of giving everyone a little time. So with those words, I guess I would like to ask our president, Jeff Keshen, who has kindly agreed to come down and give us a few words of greetings and welcome from the university. So President Keshen.
Thanks so much. I don't have a mic. Can you all hear me? Great. Thanks so much. Well, thank you for the introduction, Dr. Paranjape, Raman, for the variety of work that you do for our university and the wider community in your capacities as a teacher, associate dean, prolific and distinguished researcher. It has been a pleasure. Raman and I have got to know each other quite well. We were on a mission to India recently, where we signed some MOUs with universities and we visited high schools and the like. I also want to begin by respectfully echoing Raman's acknowledgement that the University of Regina, with its 3 federated colleges, the First Nations University of Canada, Campion College and Luther College, is situated on Treaty 4 territory. And in Saskatoon, we have a campus that contains social work and part of our nursing program, and that is in Treaty 6. Our presence on this land is certainly a privilege and one we do not take for granted. With that privilege comes responsibilities that we must fulfill, both as an individual institution and as part of the wider provincial community. And many of those responsibilities are related to sustainability and the environment, something that we are acutely aware of as April the 22nd is Earth Day. The commitment to environment and to climate action is an important part of the University of Regina's 2020-2025 strategic plan, which is entitled All Our Relations, or with my unintentional mispronunciation, Gakeyaki Wakamakanoak, in the indigenous languages of our territory. And one of the objectives here is to reduce our ecological footprint. That is, as Raman says, our GHG emissions. Our goal is to reduce them by 25% by 2025. And we are making, despite the fact that it is quite a challenge, we have made substantial progress towards that goal. And as an institution, one way that we are doing it, and I think the theme is our built environment. We're supporting these objectives through a variety of means. We've established an energy manager position, which is the first for our university. We have established a sustainability office, which is a first for our university. Creation of a sustainability action plan. The action plan will be under the umbrella, the responsibility of our sustainability office, and the many research endeavors and partnerships we have underway that go beyond the institution itself and into the wider community. These include partnerships throughout Southern Saskatchewan. We're making progress in this regard, but of course, as we all know, there is a lot more to do. In particular, Canada and Saskatchewan to reduce our collective reliance and our footprint in the area of fossil fuels. There are decisions, actions we can make institutionally, but as you're going to discuss today, we must be cognizant of and responsive to developments beyond our campuses. Transitioning to a low carbon environment by decarbonizing Southern Saskatchewan can take many forms. And I appreciate Raman's comment. It's a balance between taking action and looking at also the economic and political environment in which we work. And of course, we are not alone in this. Our city, our utility companies, business and industry, our individual households will all be affected in one way or another as we move forward. That is why the Decarbonizing and Built Environment Symposia series is so important. And thank you for being here. The university is so pleased to be able to host it on our campus. I want to thank all of today's speakers, as well as those who will be presenting at future events. And above all, I want to express my appreciation to all of you who are in attendance. Your commitment to sustainability, environmental stewardship is certainly commendable. It is laudable and will truly help us, as we like to say in our university tagline, to go far together as we work to decarbonize Southern Saskatchewan for the benefit of our communities and our environment. We look forward to working with all of you in the years to come. Thank you for the opportunity to say a few words this afternoon. I hope and I know that you enjoy the Symposia series. Off to you, bud.
So we're doing this on the shoestring. Our next speaker is Greg from the city, and I take it that he'll take it over.
Awesome. This is really kind of cool for me, actually. Last time I was standing up here speaking to everybody was the fall of 1996. And I can assure you it had nothing to do with the topic we're talking about today. In fact, when I started my engineering degree at this university, climate change wasn't something we talked about at all. So I'm really happy and I'm really proud to be standing up here and talking about it right now because it is such a pressing issue. It's such an important issue for us moving forward. So let me backtrack a little bit, not from 1996, but from now. Back in March of 2022, Council unanimously adopted the Energy and Sustainability Framework for the City of Regina. This was a really, really proud moment for me as well. What it signaled was commitment from our leadership to move on these issues that are putting all of the earth, all of our society in jeopardy as we move forward. It's a dynamic plan. It's a plan to reach net zero emissions by 2050 and to source all of our power requirements from renewable sources by 2050 as well. So what does that look like? Oops, is that not the button? Is there a mouse? There we go. All right, this is what it looks like. The green line on the bottom, that is the path that is the City of Regina's share of carbon emissions to meet 1.5 degrees warming of the earth by 2050. Now, that's kind of not true as well. There's a little bit of a gap there. There's a little bit of gap at the bottom. Now, this pathway represents a real pathway forward. It's using technology that's available now. It's using, government policies that are in place now. And it doesn't contemplate, these unknowns. So there's a little bit of work we have to do moving forward. And there's a lot of research and knowledge we need to gain to meet it. Now, the funny part is that's not even the hard part of all this. The blue line at the top, that's our current trajectory. That's the do nothing trajectory. If we keep going along, doing our business as we do it today, guess what? In 2050, we have 5.3 million tons of CO2 emissions as a community, exactly the same as we had in 2016. So I'll let that sink in a little bit. If we do nothing, temperature of the earth is going to skyrocket and we're going to be in a real trouble as a species. So what do we do? And that's what the Energy and Sustainability Framework really brings forward. Now, I really appreciate the fact that we've got a lot of experts in this room because the things we're going to do to get there are broadly laid out in the framework, but a lot of them are going to take a ton of expertise, a ton of knowledge, a ton of engineering expertise to get there. So there's very specific reductions that we're going to need to see, and they're laid out in the framework. I wish I had a better slide than this, and I might actually make one because this one kind of bothers me a little bit. But what we see is we need to make changes in building retrofits. That's the pink line on the top, I'll have to work from top to bottom. Net zero new construction, clean heating, big one, renewable energy generation. We need to reduce vehicle emissions. Active transportation and transit use is a must. Clean and renew industry. Now, this is a bit of a tricky one, and this is by no means a slight on the refinery, but it's no secret we have this giant refinery on the north end of our city that's responsible for about 30% of our greenhouse gas emissions as a community. So we really need to pay attention to that as we move forward. And then my favorite, the additional actions. These are kind of the City of Regina engineers' playground, right? This is using biogas at the wastewater treatment plant. This is landfill gas capture, all those fun things that I actually get to be a part of. So those are actually the ones that, when I'm having a bad day, I go over there and I look at those and I work on those with our engineers, and it's a lot of fun moving forward. How are we going to get there? 7 big moves. This is not some revolutionary theory. Sustainability Solutions Group, our consultant, they've done this for over 60 communities across North America. And this is how they break it down, and this is how they bucket it for every community. Some of the moves are different depending on the community you are, because we are unique. City of Regina is unique. We are not Vancouver. We're not somewhere in California. It gets cold here. Our electrical grid's different. Our way of living is different, and our perception towards what we want is different. So we really need to work in a different way towards this than every other place as we move forward. So one of the first ones is retrofitting existing buildings. And this is deep retrofits on a massive scale. There's over, I believe it's 68,000 single family dwellings in the City of Regina. And a vast majority of those were built at least prior to 1980 or maybe a little bit later. As energy codes, as building codes changed, that got better. It's still not the best, but older buildings are horrifically inefficient. Number one prong of our approach is we need to reduce our energy consumption. So one way of doing that, retrofitting buildings on a massive scale. Switching heating fuel. You're going to hear Megan talk about natural gas, and I actually get a lot of conversation about this. Is you and Sask Energy must hate each other. I'm like, no, absolutely not. Megan and I connected long ago as this was being produced, and switching fuel. Our plan right now is an electrification plan. However, we're fuel agnostic. If there's a way to get there with any other fuel source, but to have zero emissions, we're on board. This is not about preferring one path to the next. It's about preferring one outcome. Also, what's the pathway of, the hydrocarbons are here. We're not going to be stopping them right now. What's the pathway forward look like on reducing our reliance where we don't need to rely on them? That's a big question that we have moving forward. Net zero building construction. This is a really interesting topic for me right now. And, a lot of the work that goes into net zero building is actually explaining to people that we're actually building net zero ready buildings. In order to have a net zero building, we need a carbon neutral power supply, and we just don't have that yet. Now, Sask Power is going to be up here later talking, and we've been talking with Sask Power, working with them a lot. And the advancements that Sask Power have been making on cleaning up their grid have been remarkable. And we really applaud their efforts as a city, and we really encourage Sask Power to keep moving forward. As we build out and we look at our energy consumption as a city and our greenhouse gas emissions, one of the greatest effects that we have when we reduce our greenhouse gas emissions is because Sask Power's grid cleans up. Every time Sask Power's grid cleans up, I phone Corinne and I'm like, yes, thank you. Our numbers went down because your numbers went down. And that's because this is a team effort moving forward. But net zero is also, it's a really fun and exciting place to be because it's all cutting edge stuff. We're building things in this province that nobody's seen before. I'll point you towards the aquatics facility, the indoor aquatics facility that we are now moving forward on. First of all, the aquatics facility itself, we're making that place as efficient as possible. Aquatics facilities, water pumping stations and the likes, we refer to them as energy pigs in the city. You want to see a place burn energy, and not necessarily burn electricity, natural gas, whatever you want to have. Those places use so much energy to heat pools, to heat space, to exchange air, to make it safe and a livable, nobody's living at the pool, but a livable place to be. So we're balancing, those comfort things with our energy consumption, but then we're bringing in these new technologies like passive heating systems, or the most exciting to me that the city's embarking down right now is a geothermal system. Deep geothermal heating for a pool. It's not that it's never been done. It's just not something we've really done. It's not been done on a large scale, and it's a real opportunity for us to really flex on, we mean this. We're going forward and we are putting our money where our mouth is, and we're going to build a system that is as close to net zero as we possibly can. Renewable energy systems. This is a really, out of the chart I showed you, it was like the biggest chunk, right? Switching to renewable energy. We're not going to stop using energy. There's no way we're going to stop using energy. What we're going to do is improve our systems. That's the second prong of our approach, right? We're going to improve our systems so that they use less energy, so that this transition's way easier. If we just went along using energy the way we do right now, we said, let's electrify everything. Our electrical grid, quite frankly, and Sask Power can call me out on this later if I'm wrong. If we electrified everything right now to supply our energy needs, we would not have enough energy in this province to do so. So we need to reduce our energy consumption and then work with our partners at Sask Energy and Sask Power on how do we transition and where do we use the energy where we need to use it. And I think what you'll see there is there's going to be a two-pronged approach there, and especially from the city as we move forward. Our approach is rooftop solar is great. We're putting rooftop solar on everything we can. Things like pools, Wascana Pool, we have rooftop solar, and that's a great example because the pool is used in summer. Guess when we get the most solar power out of it? So there's a really good bang for our buck there. But then there's going to be large scale solar, and we're in talks with SaskPower right now about how can we work with SaskPower, what opportunities are there for the city or other partners to have, you know, we're talking massive scale solar or wind or other generation as we move forward. Emissions-free vehicles. This is a fun one, actually. The vehicles themselves are super fun and they're neat and they're super easy. I can go buy an electric bus. I can go buy, well, if they're in stock, I can go buy an electric car. Super easy to do. They're really efficient. They're great for the environment. Even with today's grid, which some people will call a dirty grid. I don't call it a dirty grid. I just don't call it a clean grid. We're still seeing savings of probably around 30% on emissions by making that switch to electric vehicles. But then we need power for these things. So like our bus fleet, we have a plan to electrify our bus fleet moving forward. And what that means is we needed 9 megawatts additional power at our bus facility. Well, we currently draw peaking about 4.5 right now. So that tells you the magnitude of the increase we're looking at on the electrical grid. And, you know, working with SaskPower, it's been fantastic. I'm going to say a lot of nice things about Sask Energy and SaskPower and ASHRAE and all them up here today. But it's been great. And these partnerships have really helped us along the way, because if we didn't have these partnerships, none of this would move forward. Increasing active transportation and transit use. Now, if you look at the plan, this is probably one of the smaller effects from a greenhouse gas and even money savings perspective, but we need to take equity into consideration here. There's people in our community who, quite frankly, cannot afford an electric vehicle. There are people who cannot afford to do a lot of the things we're talking about. But what we can do is make our community easier for them to get around. We can make transit accessible so that they can get to where they want to go on an electric bus, right? So they don't get farther behind. One of the real keys to making this change is an equity component, and making sure that as we progress, the people who can afford to, you know, put solar panels on, buy electric cars and whatnot, that's great. Let them do it. How do we incentivize, or how do we support, you know, rental community or rental properties? How do we support low-income housing and things like that so that it can be effective, and then they can reap the benefits of the savings moving forward as well. Re-energize clean industry. You know, the best thing I can say about this, and that almost sounded bad, the best thing I can say is a really good thing I can say about this is every industry I've talked to, whether it be Viterra, whether it be refinery, they all have decarbonization plans, and that's the first step. And, you know, up until 2022, City of Regina didn't have a decarbonization plan. So, you know, I think everyone can see the first step is have the plan, understand how we can move forward, and then start solving those technical issues as we move forward. Because with no plan, you're never going to achieve those goals moving forward. Let me see. I had these other slides, but I just spoke to them because I wanted to have them there in case I forgot what I had to say. Other actions. The fun zone, as I like to call it, because, you know, everybody laughs at me when I get in front of a crowd at City Hall, start talking about the good old days where I dealt with poop, pee, and garbage. Because, you know, that's what I lived. It was fascinating. It was awesome. But that's also one of the areas where we have the best potential to reduce our own corporate emissions. Landfill gas is responsible 61% last year of all city emissions from the landfill. So if we can tackle that, we can really have a big impact. But then we have these huge plants that have bioreactors that make methane, and all we do is burn it off. Well, guess what? Methane can be converted to renewable natural gas. Maybe Sask Energy wants to buy some. Maybe we want to put it back into our system. We have 70 million liters of wastewater rolling through that place at anywhere between 10 and 20 some degrees. Well, that's a lot of heat to capture, to put back into the plant. Take it off of the natural gas. Increase recycling rates. Everybody's going to see some green carts rolling out. That's a huge part of this. Landfills are our biggest culprit. We get the organics out of the landfill. We get rid of those emissions in the long term. And then spatial densification. This is one more around complete communities. People see densification and they think we're going to pile people on top of each other. That's not the case at all. We need density where it's appropriate. We need shopping. We need transit. We need it within close proximity so people can walk to it or ride their bike to it. So it's not drive your car to the bus, then take the bus downtown. It's walk to the bus, take the bus downtown. Those are the kinds of things that we're looking at moving forward. And that's really the high level. I could talk about it. We were just commenting. I could talk about this for like 8 hours because it's such a big plan. But if you want to know more about the plan, website's up there. If you just type renewable Regina, it'll take you there as well. Took me forever to get the right URL up there because I couldn't remember what it was. But I'd be happy to answer any questions that anybody has right now. Or if you want to chat later, feel free to reach out if you're not comfortable asking a question here.
We have about 10 minutes for questions between speakers.
So as of now, what would you see this group or a working group? What would be the #1 or 3 priorities that would assist the city in achieving their goal?
So I think I'll put it on 2 of them. Residential retrofits it's hugely impactful. It is hugely, tremendously difficult. And I don't know if any jurisdiction has really got it 100% right now, but I know there's a lot that are doing a lot of work on it. It's a lot of work to look out to the world and see who's doing what and what's successful. So I think research into that, but not on, okay, let's think of a new novel idea on how it's being done. What's being done out there in industry? Who's doing this? How do we get groups like that involved? What skills and talents do we need to replicate that in our own world? The other is switching heating fuel. You know, we're like fuel agnostic. Absolutely. What's the right mix? Like, I don't think I stole this from a podcast I heard, and then I repeated it to a reporter once, and everybody's like, wow, that was a great quote, Greg. I'm like, yeah, I came up with a good one, didn't I? There's no silver bullet. There's a silver shotgun shell, right? What's the mix? And, you know, the renewable energy sources are so new and there's not enough of them out there. So what's the mix so that we can have the supply that we need to move forward, but also, you know, reduce our carbon footprint. And I'll add to that, like, I'm okay with reducing our footprint if it means progress forward, as long as we're doing our best. If we're waiting for perfect, we're gonna be in 2060, and you know, half this world's gonna be underwater. So I'm satisfied with everybody doing their best and making progress forward. So those are the 2 I would say.
I'm sorry to interrupt. Could you use a microphone?
Do I need it, like, if I just stand closer, is that better?
Well, there is another space mic.
Is this one?
Yeah,
Is this work?
Is that working?
I don't know.
Yeah, it is
Okay,
working.
cool. I'll just hold it. Yeah, go ahead.
We do have a questions like those 7 big moves, right? We engineered with things in terms of numbers. So you guys have any numbers in what we say by a certain time, we're gonna have so many electrical chargers for our EVs, and by this time, we're going to rapidly all these you know what I'm saying, that so that we can achieve the net zero by 2050.
Yeah.
Can you repeat the question, because the recording won't catch it?
I think the question was, and correct me if I'm wrong, just about, you know, the numbers behind the big moves, and, you know, for instance, in electric vehicles, how many electric vehicles by when, and things like that. So there's 32 actions that are spelled out underneath the big moves that get into more detail, and then we lay out a time frame. So if you go to that website and pull up the framework, like I said, it's not a super prescriptive framework, but it does give a timeline on when we need to be doing these things by, kind of in a broader scale. The actual numbers themselves are like built into the model, and they're a little harder to pull out, but we do have like a everything by this date kind of thing, if that makes sense. And for some things, oh, I don't have that one on this. I had it on the one this morning. We do have, you know, the pathway where every year we want to be as a community. Now, the trick there is that it's a modeling exercise. We don't go out and actually count every ton of carbon coming off of everything throughout the community. We do that as a corporation, but as a community, that's way too difficult to do. So we're only planning on modeling. Well, Ying says we can she's looking at how we can do it more often because everybody's interested, but it's a 3 to 5 year kind of exercise depending on how we're going, because it takes 6 months just to model the darn thing right now. Does that answer your question?
Yeah.
Perfect.
How many kilometer of bike lanes are built?
Well, that's a great question because in the transportation master plan, they're going to be opening up. Those are the kinds of things that we're going to be building into policy moving forward. Some of the less, interesting parts for some people, not for our policy folks here, of course. There's some policy folks from the U of R here, I see, or not from the U of R, from the city of Regina, I mean. How do we build this into policy to ensure it happens, right? And then from that policy, then our engineers go into it and start building it out. So.
Question about pathways. So you've got modeling for the pathway for the community as a whole. And then there's pathways for, say, individual buildings. And I'm wondering, my husband and I have been searching for a house to downsize into and deretrofit, and it's really hard to find a suitable candidate. We've looked at lots. What have you found, if anything, from your recent sort of pilot study where you put some grant money out there? And are people doing things that are on a pathway to net zero for that building, or are they just doing something that goes part way and then is going to have to be undone when you do the deeper?
So we can only tell to a certain extent from what we see coming in. But anecdotally speaking with some of the folks doing the work, a good portion of it's going to solar panels right now. However, they are doing roof replacements before they put the solar panels on to improve their insulation value so they don't have to come and rip it out later, right? So there's some folks who are just, I'm putting on solar, that's it. Some folks are like, I'm taking my whole roof off, I'm re-insulating, I'm putting solar on, and then I'm good for the lifetime of my, 20, 30, 40 years, whatever it is, until we need to pull those panels off. So it's kind of a mixed bag, and we're waiting for the program to end to really start digging into the information in its entirety. But that's generally what we're seeing. And it's mostly solar panels, some doors and windows and whatnot, but that's really what we're seeing right now.
Hey, great. Thank you so much. Thank you to the university. This is really, really good work. And I'm really impressed with what the city of Regina is doing. I'm all about the 17 goals of sustainable development, and the university is also accepted that, which is applaud worthy. Would you consider, I know you probably have to do a lot of presentations, would you consider peppering your presentation and putting in some of the 17 goals? Because they hit, the 17 goals hit on equity, sustainability, affordability, it's all in there.
Yeah, and depending on who I'm presenting to, I'll bring those components in or I'll pull them out. This was more, I thought, an engineering type one, so I wanted to stick to more.
Coaching on 17 goals.
But I really wanted to focus on this one, just on the technical, but absolutely. And that's something that we are working with Johnson Shoyama and some others on, just to understand what those are, and we'll be participating more with that in the future. I want to ask you a question, Roy.
Okay, great.
So at BOMA ASHRAE this morning,
Yeah.
dead last presenter, and I get to headline here. Did I do something to upset you?
Never, Greg, never. That was a good presentation.
Okay, last question.
Could you just maybe over some of the affordability things that you have in place to get companies happening?
Repeat the question.
Yeah, ask me about some of the affordability things to get going. And we're not terribly far down that path, but it centers around. So I'll give you an example just to kind of to show you. There's someone renting a house, and it's horribly inefficient, built in the 1950s, and they're not going to renovate it. They're not going to update it. They wouldn't have the money to do it anyways. How do we either incentivize or regulate that owner of that building needs to upgrade that building so that that resident can reap the benefits of having lower energy costs and things like that? Like, we really need to do a big jurisdictional review on this and see what other communities are doing, but it's really the toughest part of it that there is. The other part is how we invest in transit and things along that line. You know, the cost of transit, especially when we start moving to electric, the capital costs are really high up front, but then the operational costs are lower as we move along. And are there ways that we can finance these things differently to reduce the cost to our resident moving forward? And those are kind of some of the things. I know that's not a lot of detail, but it's definitely one of the trickier things we're going to have to deal with.
It seems like it's the main barrier to getting a lot of these places, just everybody looks at the economics and yeah, it's just putting up that front capital cost that goes in, it's just.
Yeah, and the capital costs are higher up front, but the savings on fuel, on efficiency are so great, but you know, they're in the future. And as a species, I think we're very short-sighted. But other cities, I believe like Halifax, have put revolving energy funds together and things like that, so that the savings can be reinvested and we can move forward. So.
All right, please join me in thanking President. All right. So our next speaker stopped. Our next speakers are going to be actually from Sask Power and Sask Energy. Greg was just talking about how much they're doing. Now you get to hear directly from them. So that's wonderful. Dallas Monroe works for Sask Power and Megan Bunny works for Sask Energy. I'm not quite sure how we're tag teaming this, but I guess Dallas, you're going first. Okay, so I will open up that presentation. Sorry. Show me here, Dallas. That's it. Is there some way to make it into a full screen? Or is this one? I don't know. Okay, so watch yourself. Okay. Let's just make sure that the screen share is gone.
And then just arrows?
Yeah, just arrows. Coding's still running. Okay.
All the slides up. though.
Yeah. Okay. Good.
Okay. Can everyone hear me? Really well? No.
Can you turn up the volume a little bit?
I don't know how. Where's the mic?
It was just.
This.
Yeah.
How's
The mic
that?
should be
Can you hear
on.
me now?
Just need to clip it.
Yeah.
Answer? It should be on. Speak.
Can you hear me now? Am I loud enough?
Yeah.
Awesome. A little bit more? Try and talk loud too. Okay, how's that? Everyone can hear me okay? Okay, so what I'm going to talk about with Sask Power is where we're currently at now, where we're going and how we're going to get there and how we can help customers also get there. So obviously talking about decarbonizing buildings today. Excuse me. So Sask Power's mission, ensuring reliable, sustainable, and cost-effective power for our customers and the communities we serve. So first, just looking at Sask Power's current supply mix in Saskatchewan. So we're looking at currently generating about just over 5,400 megawatts, 40% natural gas, 11% wind, 21% hydro and hydro imports, 4% other, and in that other category, about 1% of our generation comes from solar, and a little less than 1% comes from other sources like heat recovery projects. And then you can also see, you know, that other category in the bottom right on the slide. CCS or carbon capture and storage, solar flare gas, waste heat, landfill gas, and biomass. And of course, the conventional coal is still at 24% of our grid, which I'll be mentioning as we go forward. I think Greg made a really good segue to this, like talking about electrification and kind of the dirty grid. I think some people are calling it. And as we move to retire that coal, the grid will be cleaner, making electrification more beneficial as in terms of like an emissions standpoint. Okay, so that's what we currently look like. So our path to net zero, so working to decarbonize Saskatchewan's electricity grid. We are on track to reduce emissions by at least 50% by 2030. So looking at wind power, we're adding 600 megawatts of wind. So 200 megawatts at Bevikar. I don't know if I'm pronouncing that right. Bevikar wind energy project near Kipling. And that's slated to be in commercial operation by the end of this year. Then SaskPower will also competitively solicit another 400 megawatts of new wind to be added by the end of 2027, and that's in South Central Saskatchewan. And then possibly also by 2030, adding another 600 to 1,000 megawatts of wind. So then on the solar front, we have 460 megawatts of new solar generation in development currently. So 100 megawatts solar facility will be built in the Estevan area, expected to be into commercial operation by the end of 2026. And then a competitive solicit for another 300 megawatts of solar in South Central by the end of 2027. And then we have some customer programs that also contribute to that solar. So we have 20 to 25 megawatts coming from the Power Generation Partner Program, and then another 40 megawatts coming from our net metering program. So, you know, adding the wind and the solar, there's lots of plans in place to get those on the grid. Currently, we have approximately 35% of our total generating capacity in Saskatchewan coming from renewables. It's interesting, when I started at SaskPower 15 years ago, I remember that number was 4% renewables on the grid, and it was made up of 100% wind. So it's, you know, in 15 years, we've come to 35%, and that includes a lot of wind and a lot of solar and others as well. So really, we are making progress. I'm not quite there yet, but we're getting there. So this is all kind of, you know, what we're putting into planning to our net zero in future. That planning also includes evaluating all power sources that will be available to us to achieve that mission of reliable, cost-effective power for our customers. So looking at things, you know, in addition to the wind, solar, natural gas, biomass, and kind of what our current mix is, we're also looking at geothermal, natural gas with carbon capture storage on the natural gas facilities. Utility scale storage will be an important one, and also small nuclear. For more information on kind of, you know, what we are investigating and what's in our plan to develop, you can go to saskpower.com/our-power-future, and then there's links in there that kind of go to what some of the current projects are. And there's also a link on that page as well to give input, which, you know, SaskPower, as we go forward, we're always looking for that input and how we should be proceeding, customer relations and such. So SaskPower also realizes that, you know, we have our own buildings in place and our own facilities from an operational and business perspective. And we are taking steps to reduce our own internal energy management. So for new building standards, we have, they include the LED lighting, high efficiency equipment, sunlight harvesting, lighting control, building automation, and solar. And so some examples of that can be seen at SaskPower's facilities, the service centers in Yorkton and Rosetown, as well as our TS&R building, and then our logistics warehouse complex in West Regina, all have solar panels on them. Occupancy standards for temperature range controls, so complying with ASHRAE standards to ensure that the appropriate temperatures for office workspace and limiting the interactive effects of human activity, turning up and down the thermostat constantly. Retrofitting buildings, again, so same as, similar to the new building standards where you incorporate LED lighting with occupancy sensors, high efficiency HVAC, building automation upgrades, and removing old refrigerators that are obsolete and energy hogs. We also are, looking at EV charging for our fleet. So we have several electric vehicles and chargers around the province and looking to add to that as well. And then we also have waste recycling and composting, working with our waste management vendors to reduce our materials going to the landfill. So those are kind of all things that SaskPower is looking at from our properties and shared services departments that as part of our internal energy management. So going forward, that goal of 50% reduction in emissions by 2030. So this chart just kind of displays all of what I've talked about kind of wrapped up into the trending downward. You'll notice that little blip in the little V there in 2021 and 22, our emissions at SaskPower actually increased. And that was due to decreased hydro availability, increase in demand, customer demand, and a decrease in availability of our carbon capture and storage. But you can see in the chart, that downward trend toward reducing the emissions by 50% by 2030. So that's, what SaskPower has, what we're doing, where we're going and how we plan to get there. And of course, how are we going to help our customers get there? So this slide I'm just including to kind of show the diversity of our customers. The three main segments that we work with: residential, small, medium business, and then key and major accounts. So those are those really large industrials or large commercial. With different priorities as well. Like you'll notice the industrial, like those key and major accounts account for a small portion of our accounts, but a large portion of our revenue and consumption. Whereas the residential, there's a very large number of accounts, but responsible for a significantly less consumption and revenue. So it is a challenge to kind of meet all those priorities. Specifically, acknowledging the differences in priorities between each customer segment group. And really looking at affordability. So SaskPower, going forward, is focusing on affordability for our customers. We know that that's the growing concern, and customers are looking for options and support from SaskPower. And the best way to manage those energy costs is to be more energy efficient, and which also then in turn reduces greenhouse gas emissions. So SaskPower is committed to providing options for customers to meet those affordability concerns while decreasing emissions. So in addition to SaskPower's home retrofit program, or sorry, wrong name, SaskPower's Energy Assistance Program and the current Northern First Nations home retrofit program, SaskPower is developing plans to come out with programs in the future for those three different customer segments and more. And so working on those plans. So stay tuned for future updates on those. And that's what I have. So I'll maybe pass it over to Megan Bunny from Sask Energy.
I'm not sure the Zoom was working. So.
No, it looked like it was all.
But it is recording. I don't understand. Okay.
Was it just about getting the video computers?
Yeah, here, yeah, where the video is. Which one is yours?
Yes, I see.
Sure.
Presentation.
Oh,
Oh.
sorry.
Yeah, let's do that. Right, that's up there already.
Is
That's
it?
great, yeah. That looks good. Can you hear me with the mic right now? High or low? Someone said no. Okay. Perfect. Okay. I'll just see if there-
Keep yourself in.
Is there more volume? Just this one?
Just,
Oh, I don't think that's volume. Does somebody know how to operate this? Or I'll talk louder. Is this good? I'm not seeing a thumbs down anymore. Okay, I'll go with that.
All right, good.
Hey, thanks for having me. Megan Bunny, I'm Manager of Market Sustainability at Sask Energy in our Customer Solutions Group, which generally focuses on energy efficiency programs for our customers, so rebate programs, as well as the role of natural gas in the future in a decarbonized environment. My arrows aren't working. Oh, there. Delay. So you already heard from Greg and City of Regina. So one of our big customers has goals to get to net zero, and they're not the only ones out there. So as part of that, we also hear a lot about electrification, and years ago, that was the one pathway that people talked about when we talked about decarbonization. And part of what I have learned over the years is that there are other ways forward. So as part of that, Sask Energy sees a future where gas is part of that future and has committed to environmental sustainability and economic prosperity for future generations. So both are important. We're also committed to providing a critical energy for greener Saskatchewan. It's cold here and we need our energy to be supplying us throughout that winter season. Reducing emissions internally, so looking at our own internal emissions and reducing those by 35% by 2030 is a commitment we've made, and we're on a pathway to reach that target. And then the third one is about our customers. A lot of the emissions with natural gas are the end use of that gas itself. So how can we expand our programs, our service offerings, as well as education to help our customers towards those low carbon, net zero, and sustainability goals? So a few years ago, we had a potential gas pathways study done. So how can gas support net zero buildings in Canada? And as most of you would know, the energy mix in Saskatchewan is very different than in other provinces. So that yellow portion is the amount of natural gas that is used in buildings. And I believe it's highest or second highest in Saskatchewan compared to all the other provinces. So there is a different mix of energy that we need to consider here. And what was found through this is that there are pathways to get down to net zero. That first piece is the most important that needs to be addressed first, and that's energy efficiency. So reducing the gas demand or reducing the energy demand of the buildings is our first step. After that, bringing in low or zero carbon gas supply, and where that's not possible, offsetting that gas with carbon capture, emissions, negative emissions technology. So one example of gas in a net zero building is a net zero MURB that is in Saskatoon. It's net zero energy and net zero ready. So it's not fully addressing that emissions piece, but it's a starting point to show there are solutions out there. So this building was actually part of a Canadian Home Builders Association challenge, and there was one builder in Saskatchewan chosen, and the goal was affordable, comfortable, net zero ready housing. This example is currently being occupied partially by low income families. So that is demonstrating the affordability of the solution. And from a technology perspective, there's electric air source heat pumps, both for the water heating and the space heating, as well as very small, high efficient gas furnaces and smart thermostats to maximize when it's switching between those pieces of equipment. The design process for this, it followed LEAP's local energy efficiency partnership. So this is about bringing people together. So we had a design charrette, there's designers, there's people from many different perspectives coming together, and then energy modelers going through a bunch of scenarios to say, okay, cost, technology, energy use, what are all the possible solutions? And the builder chose this particular solution. So yes, it's possible with today's technology to get to that net zero energy ready. More in the energy efficiency realm is how do we help our customers reduce their energy efficiency with the technology that they have. So with the equipment that's in their homes, and we provide rebates to incent customers to really put in equipment that is higher than what's required by codes and standards and regulations. And currently we started this program for a residential market in 2019 with a 5-month program, and we've now extended year round to offer those rebates. So there's more certainty and there's no end date, which also allows for flexibility to make changes to the program as needed to keep meeting customer demand. And as we have more data to educate us in those decisions. Similarly, with our commercial customers, we offer rebates for energy efficiency equipment. So furnaces, boilers, water heaters, HRVs, infrared heaters. And again, that's a year-round program that's available. But we also know there's more we can do. And to better understand that, we are currently engaged in a conservation potential study for energy efficiency in the gas realm within the entire province of Saskatchewan, looking at residential, commercial, and industrial facilities. So all gas use within the province. And essentially what this study is, it's a quantitative analysis of the technical, economic, and achievable potential. So technically we can do a lot. Economically, we can do another amount, but then there's other factors that will actually take that achievable potential to not be as high as the other ones. So that's taking into account the market, and maybe it's the education, it's things that will hopefully be, it's barriers that we can overcome through some of the work that's being done in forums like this. So when Greg was talking about their plan, they used technology that's available today. And we also know that there's technology that will be available in the future. So how can we help companies develop that technology? And one of those ways is we're a member of the Natural Gas Innovation Fund, and it's gas utilities. And now there's actually producers involved as well. And it's really, it's a non-dilutive funding grant that's offered. So we don't have any stake in the technology at the end, but we are helping these companies move their technology towards market and being commercialized. And the goal of it is really to focus on technologies that will improve both the environment, so reducing emissions, as well as being more affordable. So it might be, how is renewable natural gas, how can that be more affordable? Or what new technology for end use customers could help achieve those net zero targets that are out there right now. So a couple examples I'm going to talk about. The first one is a gas heat pump. And one of the pieces that's really important to me being part of this group is, how do we demonstrate, or not how, but can we demonstrate this technology in Saskatchewan or Northern BC or Edmonton, where the climate is similar to here? Because some technologies will work well in warmer climates, but we need something that is going to be working in Saskatchewan to meet our needs. So electric heat pumps are commercialized for residential customers already, and a gas heat pump is a similar technology, but it's using gas, and it's still achieving that higher than 100% efficiency or coefficient of performance greater than 1. and also able to operate down to our cold winter temperatures. So we are demonstrating one in Saskatchewan at our training center, and it's providing heat so far and will provide cooling and domestic hot water. And when it was operating, I think it was around December, we got some data back, and even in that cold stretch of weather, it was still operating at that efficiency higher than 1. And that's part of regulation changes as well. So there are targets from NRCan that all space and water heating equipment will eventually need to be more than 100% efficient. And this is one potential solution that could meet that.
Megan, is a heat pump essentially just a boiler system?
No, it's more like an air conditioning system in reverse. But it is for space and heating, and it can be like a boiler system is for hydronic heating. And then your furnace is mechanical engineers out there, help me, not hydronic.
Actually, it's sure, we have a whole presentation.
Yeah, we have.
Okay. Perfect.
Heat pumps too. I don't think anybody is familiar probably.
You're gonna know.
Good.
You're gonna get too much.
I would give a very high level from an electronics engineering background, and you've got your expert right there. Yeah, thermodynamics is definitely important here.
It's the same thing. I just want to confirm because like we've been using boiler systems in Saskatchewan for years. It's what keeps my house.
Yeah, different technology.
Okay,
Yeah, higher efficiency.
thank you.
Another technology that we have helped to install first of in the province is a small scale carbon capture unit. So this is designed to integrate with your boiler systems. If you're not ready to take out that boiler system, this is a solution to tie into that flue gas and capture the carbon out of it, convert it into a potassium carbonate, which is a solid carbon product, which is then it goes into that circular economy. And in this case, the company that makes this technology collects it and turns it into soap products. So it's permanently sequestered and not creating GHG emissions. Another benefit that comes from this technology is it's an exothermic process, and it actually preheats that boiler water. So not only are you taking the carbon out of the flue gas, but you're also reducing the energy needed to actually heat your system. So we talked about energy efficiency. That bottom part of the graph from the beginning was carbon capture. And then the middle one was decarbonizing the gas. And two of the ways to do that with natural gas, one, or I won't say with natural gas, but in a gaseous system is renewable natural gas. And the other one is hydrogen. And so today we are able to physically move renewable natural gas on our system. We don't. And we are taking steps to move towards that. One of those steps was a customer survey last year. So, you know, what is RNG? What do people understand? Do they know what that means? Only 20% of customers actually knew what RNG is. So there's great opportunity to increase knowledge around that. There are RNG purchase programs in other provinces. So that is a potential model that we could look at in Saskatchewan as well. Right now, we're working with a consultant to ensure that bringing RNG on to the system can be done in a safe way. So once we get that piece sorted out, we can look at our next steps. Hydrogen is another technology, and not technology, another gas that can be used for heating. And there are currently 2 projects in Canada. One's in Fort Saskatchewan, Alberta, another in Markham, Ontario, where they're blending hydrogen into the gas system, and that is going into the community. The technology that's in customers' homes is also very important to understand, and what's the impact on that technology. So we're part of a joint industry project where we're taking specific pieces of customer appliances technology and testing them with various hydrogen blends so that we can understand the impact on customers, because we need to ensure that we're putting our customers first when we're making any changes. So for now, we're very much in that learning stage with regards to this. I threw out a few questions, but one I think Greg touched on is, what's the RNG potential in Saskatchewan? I really want that answer and I don't have it. But yeah, generally, like, what are the pathways to decarbonizing the built environment in Saskatchewan? The study that we did with our counterparts across Canada was a Canada-wide one. So what does this look like in Saskatchewan? Because what works here may not be the same. And what are the economic impacts of those pathways? From a national perspective, we found there's a lot of gaseous infrastructure already installed. Is there a way to leverage that existing infrastructure to decarbonize our energy systems? What technologies show promise and which ones should we watch? But also, what are the market barriers to those? Like, that's a really important thing that we need to address when we look at heat pumps, for example. We're looking at that, like, how can we move that along the adoption scale, and awareness and availability, accessibility, affordability, and acceptance of these technologies is really important. And also the people and training, the people that are actually going to work on these systems. And then there's also behavioral changes that can happen. And sometimes there's low-hanging fruit with that. Like, what are those easy things that we can start to implement today to reduce the energy we use through our actions? And then how do we measure impact? So I'm going to get Dallas to come back up with me because we're tag teaming here. And we match. We didn't even plan this. But we had Green Day at work, and even though I'm not there, I decided to follow along with it. So
Nice. So questions?
questions.
We only have 2 minutes though.
2 minutes. Okay. Yeah.
That project you cited in Saskatoon, how much effort and expense was put into improving the building envelope with the actual energy requirement down in terms of insulation and so?
Oh,
Try-
the net
try to
zero
repeat
building
the question so that we
for the project in Saskatoon.
Yeah.
How much energy?
Well, you talked about, reducing the energy required.
Yeah.
What insulation levels did they use? Did they spend a lot of money on windows and all of the other things that are needed in a building envelope to have a efficient building?
That is a great question. I don't have the answer on what insulation value they used. I don't have the answer on the cost. I know it was done to be affordable, and I think that's demonstrated by it being low-income families living there. So the goal was really keep those costs down, and I believe it was on par with other houses, but I would have to go back to the builder and get that information.
I have a quick question, like how many more engineers that your organization need to hire in the next 10, 20 years while you do this energy transitions?
How many engineers? I know I need lots. Can you talk to my HR department and get me some?
Dean of Engineering.
Yeah.
All right, I think
I don't know
we
how
are
many we need
ready
some.
at the end.
Hydrogen. It is not being blended in Saskatchewan. There are 2 projects in Canada where it's being blended. One is in Ontario, one's in Alberta. We don't have a timeline on that.
All right. Thank you very much.
Oh, not that one.
Okay, so our next speaker is Kai from the Building and Technical Standards Government of Saskatchewan. Which one is yours? Okay, so you got to share the screen. Share the screen. This one, right? This one. All right. Okay, the microphone is here. You have to hang this.
I'm a quiet guy, so I'm gonna put this on. Maybe. Maybe I'll just hold it. Can you guys hear me okay? Okay. Anyways, welcome. Thank you greatly for the opportunity to let me speak here today. As mentioned, my name's Ty Twite. I'm the building standards engineer here to speak to you on behalf of building and technical standards of the government of Saskatchewan. I put together this presentation under the assumption that members of this audience are diverse in terms of their understanding of the Saskatchewan legislation that's related to energy codes for buildings, as well as the energy codes themselves. So we will try to go through a few key points on this agenda. Start out with building and technical standards, who we are. We'll talk some about the national model codes, the legislation around the energy codes, both current and proposed. Comparison of compliance paths options that are within the codes, the tiers in the codes themselves, proposed buildings versus reference buildings, and some of the simulation data that we've kind of developed over the last, say, couple of months. So anyways, building and technical standards is part of Central Services Division within Ministry of Government Relations. So BTS is responsible for developing, adopting, and implementing construction codes, legislation, regulation, and technical safety policy for Saskatchewan. And we are the interface for executive government and the Technical Safety Authority of Saskatchewan. BTS is responsible for the Construction Codes Act and the following regulations under this act. So building code regulations, energy code regulations, and plumbing code regulations. National model codes. So as part of the Canadian Free Trade Agreement's regulatory reconciliation and cooperation table, the Government of Canada announced a new governance model for the National Model Code Development System, effective just half a year ago in November. It replaces the Canadian Commission on Building and Fire Codes, the committee responsible for code development since 1991. The new model integrates the provinces and territories into the national process to better respond to code priorities from jurisdictions and to harmonize construction codes across Canada. So Saskatchewan participates in the national model code development process at multiple levels. The highest level is we always try to shorten these down, but Canadian Table for Harmonized Construction Code Policy. So we'll call that the policy table. Canadian Board for Harmonized Construction Codes, and that's the codes board. And then underneath them, there's various subcommittees and task groups. So one such task group is task group on operational greenhouse gas emissions. Within our branch of government, it's actually my deputy minister that's a co-chair at the policy table itself. The chief codes administrator, who happens to be my boss, sits on the codes board. And I'm fortunate enough to have been invited to be a member of the task group that you see here. So we're going to be having our third meeting later this month and just getting into development of operational greenhouse gas provisions that may become part of the code soon. Currently, the national model codes work towards decarbonization through implicit means rather than explicit means via reductions in building energy consumption. Right now, explicit operational carbon requirements will likely be published part of either the 2025 code edition or the 2030 code edition. Not sure. Explicit embodied carbon requirements will be further out than that, so likely the 2030 or 2035 editions of the codes. Construction Code Act, the Building Code Regulations, and the Energy Code Regulations are the mechanisms by which Saskatchewan adopts, amends, and implements the model national codes, except for fire. This is throughout the province. This point is something places like Saskatoon and Regina may begin to utilize in the next little while, but local authorities adopt building bylaws in order to carry out their administrative and enforcement duties, issue building permits, and collect building permit fees within their municipalities. So Saskatchewan's provincial legislation allows local authorities to adopt higher energy code tiers or standards higher than those legislated by the province through this building bylaw adoption process. So the legislation that's currently in place, the Energy Code Regulations, it brings in the National Energy Code of Canada for Buildings 2017 edition, and it applies to buildings constructed on or after January 1st, 2019. Under the Building Code Regulations, Section 936 of the NBC 2015 is in force and applies to buildings constructed on or after January 1st, 2019 as well. Both of these codes, the NECB 2017 and Section 936 of the NBC 2015, have three compliance path options in terms of building energy consumption. So prescriptive, trade-off, and performance. So what's being proposed for legislative changes right now to the Energy Code Regulations is that the 2020 NECB would be adopted and enforced starting January 1st, 2024. And it would apply to buildings constructed on or after January 1st, 2019. Same thing for the Building Code Regulations. It would adopt 936 of the NBC 2020, would be enforced on January 1st, 2024, and it would apply to buildings constructed on or after January 1st, 2019. So you can see there's a component that's still missing. So that's it, alterations to existing buildings. It's a code that's there, it is being worked on right now. Not sure when it'll be published, but look for it in the next code cycle. That would likely apply to all the other buildings that the NECB and Section 936 do not apply to. So the proposed changes to compliance path options will affect both codes, the NECB 2020 and Section 936 in the NBC 2020. Under the NECB, tiered performance path would be the only option going forward, starting January 1st, 2024. Under the NBC 2020, there would be two paths available, both of them tiered, the first one prescriptive and the second one performance. The other larger change would be collapsing Saskatchewan's 4 climate zones into a single zone. So that right now we have zone 6, 7A, 7B, and zone 8. And the majority of the population in Saskatchewan lives in zone 7A. So thought I had more notes on that one. So this is just a comparison of the compliance pass of the last couple of slides. Bear with me here. Shows a side-by-side comparison of the paths and options that exist today and as they are proposed to begin in January 1st, 2024. You'll notice that the prescriptive path, trade-off path, and pure performance paths are proposed to be removed in order to make way for the tiered paths. Proposed legislative amendments will mean that the NECB 2020 will start with Tier 1 performance beginning January 1st, 2024. This will continue on until new legislative amendments are proposed. Also, the proposed legislative amendments would mean that the NBC 2020 would start off at Tier 2 performance or prescriptive beginning January 1st, 2024. And this would be bumped up to Tier 3 beginning January 1st, 2025 and continue on until new legislation amendments are made. Our branch anticipates that the 2025 editions of the codes will be published by December 31st, 2025. So at that time, once they're published, we'll assess them, carry out consultations, and then new legislative amendments will be proposed after that. So what are the code tiers? Not sure how many people are familiar with the energy codes themselves, but this actually comes out of the NECB. Grab the wrong sheet. So essentially, tiers can be described as energy performance levels where each successive level improves upon the previous one. Shown here is table 10.1.2.1 from the NECB 2020. The first column contains the tiers, and there's 4 tiers in this code. You'll notice that there are 4 separate tiers. Second column contains the percentage that the second column indicates what percentage of the building target the proposed building is allowed to hit in terms of percentages. So as you move up through the tiers, your energy target that you're allowed to hit becomes lower and lower. And the third column just shows your percentage of improvement. So if you were building a building to Tier 4, compared to baseline building built to this code, you would be expected to have at least a 60% improvement on it in terms of energy. So this is another table. This one actually comes out of the NBC. It's subsection 936.7 and it's tiered energy performance compliance, the performance path. So it's the same path that we just saw the slide for, but it's tailored for smaller buildings that are typically covered in Part 9. This one, in my mind, it's at least a little more complicated. I wish they would have laid it out a little better, but they've broken everything down by the volume of the building. This I just wanted to put up to show you a little bit about it. The other thing you'll notice that's different about this one is there's 5 tiers. So difference between NECB, 4 tiers in that one, NBC has 5 tiers. This is the last one I'll show you. So this is the prescriptive tiered path. It's incomplete. The codes, when they were published, May 28th, 2022, I believe, just over a year ago now. There was major changes to this section of the code when you compare it to the draft original version that went out for public consultation. So they rushed it and they've only put data in here for up to tier 2 energy performance. So I do know that they are working on at the tier 5 level right now to flush that out. And then they'll work backwards from there to develop tier 4 and tier 3. But we're unsure at this time if that will make it into a second edition printing or if it will even make it into the 2025 edition. These ones will go through quick. There's a few terms you'll see used repetitively through the code. So there's a proposed building and a reference building, and the key takeaway for it is the reference building is always the baseline. It's what you compare the proposed building to. And the annual energy consumption is what you figure out for the proposed building, and you'll compare it to the building energy target of the reference building. Just a couple fundamental things. Go through this one quick too. This is the fun part. So modeling simulations for 8 building archetypes were conducted by NRC Research. Results appear to show that increases in energy performance are expected between a reference building built to the NECB 2017 and a reference building built to the NECB 2020. Just reference building to reference building, baseline to baseline comparison. So we did this for various types of archetypes located in Regina, Saskatoon, and Prince Albert. And what we found was for the electrically heated scenarios, simulations showed a 1 to 38% improvement in energy performance, moving from one code to the next, with an average of 13% overall. Further, all 3 locations showed similar improvement, with no location showing greater relative improvement. So this is electrically heated buildings. For the gas heated scenarios, simulation showed 4 to 72% improvement in energy performance going from one code to the next, with an average of 27%. So further, a greater relative improvement in Prince Albert than either Regina or Saskatoon, but that's likely due to PA being in zone 7B. Matched infiltration assumptions were used in the modeling data just to do apples to apples comparison. So up here, I think this is more than what we ran, but this data, so what we would do is take data out of, I think it's NREL website out of the state. So anyways. As I said, I'm an engineer. I love data, and I understand that this is quite a bit to take in. So what we've done is compile the data output from the modeled simulations in bar graphs in the next 2 slides that are specific for Regina, which contain the 8 reference buildings that are shown here. So looking at this graph, specific to Regina, the 8 buildings are shown across the bottom that were assessed. The light green is put there and it's set at 100%. So if you built that building to the reference building standard in the 2017 code, that is the value that you would get. And if you took that same reference building and built it to the minimum requirement for a reference building in the 2020 NECB, that's the savings that you would get. So even before tiers are applied, you're actually seeing a baseline improvement in just going from one code addition to the next. Oh, sorry, that was electric. This is gas. You'll notice quick serve restaurants can kind of jump off the chart with you. So there are some archetypes where the code seems to have more impact than on others. Warehouses, obviously, least amount of impact, but quick serve restaurants, most amount of impact. Office buildings, generally 20% reduction, whether it's medium, small. So I think this is a little better to look at than this one. Anyways, this just contains some information about where you can find the archetypes, pull the data from. So the NECB rules were applied to these geometries and space types with Canadian climate zones, overriding corresponding US data assumptions detailed in the energy.gov website. And Open Studio and Energy Plus software were used for these simulations. So now going to the NBC 2020. Significant increases in energy performance are not expected between reference buildings built to each of the code. So moving from the 2015 to the 2020 edition of the NBC, there's very little change. There are, however, some small differences that have been introduced. So fenestration minimum U values in that table have gone up or changed, I mean. Gas-fired furnaces now require a minimum 95% AFUE instead of 92%. And minimum performance requirements for service hot water further broken down by first hour rating. That's all I've got. I hope it was informative, and I'll take questions.
Okay, lots of questions.
I'm hard of hearing, so I'm gonna come down a bit.
I'll actually that. Can you go back to slide 12,
Slide 12.
please? It says that it's in force on January 1st, 2024, and it applies to buildings with built like 5 years before. How does that even work?
Well, the way that the energy code is set up, you can never apply the energy code book itself to a building that was never built to the original energy code. That's where you need the alterations to existing buildings code to come in. So within that code, once it arrives, it'll have energy efficiency provisions that are going to be for buildings that predate January 1st, 2019. You have to treat them differently. So example, if I built a building January 2nd of 2019, I would have had to build it to the 2017 NECB. If I'm deciding to do an addition or a major change to that building, this code applies to it again, right? But it's the code of the day. If I built one in 1980, this code can never apply to it. Yeah.
Get that part, within the energy code, we have different tiers, but at the same time, we have different types of buildings, right? Is it for each type of building, you have some substandards for, say, there's a standard for this type of building, a standard for a high rise, or standard for a single detached house? Is that true, or basically the same standard apply?
Yeah, the same.
Repeat the question.
Oh, okay. If I understand you right, you're asking if there's different standards for different buildings. No, the answer would be no. It's just implications of applying the only standard affect different buildings different ways. So that's where you see those charts up there. Like a lot of times people will ask, well, what does this mean? How much energy am I going to save? But it's really building dependent and use dependent and so many factors, but it is just one standard.
I was really interested to hear that operational greenhouse gas is gonna be part of the code.
Eventually, yeah.
Yeah, that's really exciting because when Myrtle and I were in Greece for the ASHRAE International, they said in the life cycle, there's a lot of data on carbon, embodied carbon, but there's not on operational greenhouse gas. It goes back to what Greg said, like, did I upset him? This morning? But when they were doing the Greek, when they were working on the framework in January, there's, so options were put forward. One was the heat pumps. And so, but there's an operational carbon to the heat pump that we're not looking at. And so it goes back to what Sean said is, can we afford $50,000 to put that heat pump in if the operational carbon hasn't even been measured?
You can only measure to what codes are in force today. Like every successive year that goes by, there may be a new code, or the energy code could turn into 2 books, 5 years, 10 years down the road.
Do you understand how cities, at the grassroots, we're trying to do good, but there's data it's holding us back from being successful.
It's complex, and I think that's why we're all here today, kind of these questions, and I can't answer that. And I think that's what you were referring to. There's going to be more questions here but it's a good question. I'm sorry, I'm not a good answer.
Do you think we'll ever get to the day where there are specific energy codes for watts per square meter for different types of solar?
See that?
A code that says you can only have so many watts per square meter for consumption annually for this type of building?
Say to a certain extent, it's that way for lighting. Like, there's lighting density calculations. I don't know. Codes are always evolving, so possible.
Because that's the target, really. And the other question I had was, you talked about all those tiers and improvements that you get if you go up in tiers. Where's the incentive to do that?
It's not my wheelhouse. I've got a lane and I've got a say in it. Sorry, I am gonna have to come.
My question also is this slide. The current code is not, the current plan code is not. Was not done to the on the first province. Previous codes, is there a plan to return to those provinces that construct on one code? Because these codes set minimums for energy consumption buildings. There's a delay in saying, so that's how I deal with.
Okay, don't answer. Come back here. Okay, we have a.
I've been told that. I'm kind of
Yeah, no, appreciate that. But in front, close to that microphone.
Oh, sorry. Like a timeline for returning to prescribed codes, is that what you said?
This used to be a customary document.
Yeah, can you help me out?
Yeah, well, I have the same question.
Okay,
In that, yes, it was very predictable when a code would come into effect with the code cycle.
I follow.
And now it seems we're a little bit out of step with that. Is there a plan? I know there's a big change, but is there a plan to get back to that kind of?
Yeah, so I get where you guys are going now. So yes, I don't remember what year it was signed, but there's a reconciliation agreement on construction codes. All provinces and territories signed on to it, and it commits them to adopt the code within a certain date of publication. So it's the 2025 edition is 18 months. So if they do publish it in, we'll say December, 2025, then 18 months from them is based on that agreement. That timelines you have to be cognizant of too, because from a design end of things, you don't want to bring a new code in at the start of construction season or halfway through the construction season. Historically, it's usually January, like, so. Yes, to answer your question, there are mechanisms in place that'll try to bring that back to a more repetitive cycle. Yeah. COVID kind of buggered up the 2020, got pushed back, but it was more than that too. Section 936, there was a lot of contention around how the last draft was written. And if you, one day I'd urge you to look at it, and it's startling how different it is. But did that answer it?
All right, I think we hit the time, so. All right, ladies and gentlemen, our next speaker, oh, that's nice. The microphone is definitely working. Our next speaker is Tom Atkins. Tom Atkins is a retired, believe it or not, vice president of Stantec, and has been instrumental in creating this series. Tom is going to also be tag teaming with Andy. Is Andy in the room? There he is. Okay. Who is from our Faculty of Engineering, and they're going to talk about heat pumps and, you know, I hope the lady that was asking about heat pumps is issues in the room. Really good. How are you? Anyway, so with that introduction, I hand it over to Tom.
Okay, well, thanks for joining us. I hope that I don't prove to be at odds with Google. So this is, I've talked about this with several people. Oh, first off, thanks for coming. This is a little bit of the hard part of our job, is threading the needle on how much information we provide when we have such a diversity of backgrounds in our audience, from people that have a whole bunch of technical knowledge, and then some that are new and maybe on other parts of the equation. So we'll do our best to try to thread that needle for you. And if there's anything that really gets a little bit too technical, well, maybe we can talk to you about it after we're done. So first off, I think it's really important that everybody get a little bit of an understanding on heat pumps. They're talked about in circles, lots of documentation on it. I think it's important for people to understand that it's not a singular type of technology. There's a lot of variability in it. And today, the first half of the presentation, I'm going to hope to give you a little bit of a breadth of that knowledge and see where we come from. And then Andy's going to speak a little bit on some technical areas. So hope that we give you a bit better understanding, and we're just going to move along. Okay, so they're important, and they're an important part of the puzzle of decarbonization, and they've been around forever. I can tell you that I came into engineering in the late 1970s, and they already were in the marketplace. So this is not new technology. And the best way I like to talk about when people ask, what is a heat pump? It's a fridge, right? Everybody has a fridge in their house, and it has a compressorized refrigerant system, and it moves heat out of the fridge and puts it into your house. So a heat pump, whatever technology we're talking about, is pumping heat from a source location and putting it into a sink location. So that's as simple as I can get it. And instead of pumping water, we're pumping heat. So, and and all of the components in an electrically compressorized refrigerant system are basically fundamentally the same. You have a compressor that compresses a refrigerant, and that refrigerant, there are many different types of refrigerants. It pushes that pressurized refrigerant into a condenser, which releases heat. That cooled fluid then flows through an expansion valve, a Joule-Thomson expansion valve, where it flashes off, its temperature reduces, pressure reduces, then it goes into an evaporator in which it takes on heat and thus cools that location and then returns back to the compressor. So it moves heat. Why are we really interested in it? Is because it moves more heat than it takes to operate. So if you're everything that we think of in conventional heating typically consumes more heat than it actually delivers. The one outlier is electric resistance heat, where every electron that's going into that heater comes out into the space as heat. It's 100% efficient in delivery of heat. Every other means of heating has some inefficiency in it. A heat pump is the opposite. The heat pump moves more heat than it actually consumes. And so that is why we need to think of that as part of the solution going forward. And as Ty talked about, and Megan mentioned, we do foresee a time in the near future where codes will say you have to have something that is more than 100% efficient. And so a heat pump of a type is going to be part of that solution. Okay, so one more thing on this. This is a demonstration of the energy arrows. So you have energy that goes in to run the compressor. It absorbs energy from whatever the source location is, and it rejects energy out into the sink, whatever that is. And the important thing, Megan talked about it in her talk, the thing to remember is coefficient of performance, COP. That is the measure of the amount of delivered energy divided by the amount of energy that it takes. So you'll see lots of publications where they talk about COPs, and we're going to actually use it as we go through here. So for heat pumps, there's lots of different types. On the electric side, so we're generally talking about electrically driven compressorized units. They're generally categorized by what their heat source is, mostly. So you
may have a problem with the recording. It's going so good.
Oh, that's one participating. Never mind.
Well, that's what I thought, but you told me wave them down. We're good to go.
We're good to go. Okay. So in the case of electrically compressorized heat pumps, we have a few very simple broad categories. The one that most people are familiar with would be an air source heat pump, where you're absorbing heat out of the air. Whether or not that air is outside or the air is inside, you're absorbing it out of the air. So air is the source. And it can be delivered to either air or water, depending on how it's configured. Do you want to deliver it into a furnace or fan coil system? That would be an air-to-air with an air source, or you could have air to water, air into an underfloor heating system. We also have water source and ground source heat pumps. So there are many or several different iterations of that. I'll have a slide on it a little bit later, but you're taking water for water source, you're absorbing heat out of the water and delivering it somewhere else. And there's lots of different scales. You can have this, the one that I have on the left-hand side of the screen is like an air source heat pump for a house. It's essentially an air conditioner with a reversing valve in it. Or you can do it at the community scale, which we have a picture of Drake Landing in Okotoks, Alberta, which is several sets of townhouses, a small community development that use ground source heat pumps, or they can be massive at the industrial scale. And indeed, all of these have positions or uses in the marketplace, depending on what we're trying to get. Okay, want to talk a little bit more about water source heat pumps. So the fundamental difference, or one of the limitations of an air source heat pump in a cold climate is the fact that you can only absorb heat out of air down to a certain temperature. And that is based on several thermodynamic reasons, but there are lower limits in outdoor air temperature that you can take air out of. And currently, the absolute best heat pump on the market today cannot take heat out of air colder than about -25 or -27. And even at that, it does it very inefficiently. So that's a limitation for our climate, and we have to have other measures in place to help us solve the heating problem for space heat. Water source typically doesn't have that issue because the water sources are typically not frozen. So all of a sudden you've got space, you've got a source temperature that is up closer to the space temperature you're trying, or the delivery temperature you want. And in the case of a ground source, it is very stable. So if you have ground source heat pumps, that heat is available or for use with the heat pump year round is not weather dependent. I have to say that the COPs, or the coefficient of performance, also varies greatly with them, because the coefficient of performance has a lot to do with the temperature spread between what you're trying to heat and what the source is. So the narrower the temperature difference that you're trying to overcome, the higher the COP. So you can, if you're trying to deliver 20 degrees C in your sink, and you have 0 degrees C as your source, that's going to use a lot less energy than if you're trying to take it out of -20 degrees C. So you think about the amount of work that it has to do. So the COP, just the thing to keep in mind, you get a higher COP, the narrower the temperature differences between the two. And indeed, I show the industrial one because there's many applications where you can get really kind of funky temperature ranges, and so the equipment is very has to be developed very customizable to what the needs are. Now we're going to talk about gas as heat source, as a source of energy for heat pumps. So I took these two slides to talk about the kind of two broadly typical types of refrigeration cycles for use in gas-fired heat pumps. So the first one uses natural gas as the engine driver for a compressor. So it's still a compressorized refrigeration system circulating the refrigerant, the same as the electric compressorized, is merely using natural gas as the driver for that motor. The second method, which is on the right, uses an absorption cycle, which is completely different. And it is using another refrigerant that is soluble in water to move energy. And the gas is the heat source to boil off that refrigerant and to help that cycle continue. It's completely different. I mean, we could spend hours just talking about absorption cooling. It does have its application. Again, it's been around. These technologies have been around forever. It's just trying to get them in these current applications. So what's new and what direction are going with heat pumps? First off, I should say that the US Department of Energy with Enercan has a cold climate heat pump challenge on right now. The first results of those heat pumps are actually going to come to market very soon. I think I saw something from maybe Lennox just pop up on my screen yesterday that they're going to have a new product out as for this coming heating season. So that is looking at driving up COPs and expanding the range of operation of heat pumps. We have always had progression in compressor technology. And so we have many manufacturers of compressors that go into these devices that are always working on improvements. And probably the thing that is most intriguing is now we're getting manufacturers to package hybrid solutions. So you don't have to cobble together a hybrid solution yourself. You can actually buy hybrid solutions, mixing where you have heat pumps combined with conventional heating technology. So one of the things that we've talked about last couple of weeks ago, and Megan talked about before, is we do have an issue here in a cold climate in that we cannot heat with an air source heat pump. We cannot heat a building at -40. Like, it's technically not possible. And so what do we do and how do we address it, and what is the impact of that? So if you look at the range of temperature operations or the climate, we actually don't have that many operating hours in the year that are outside the range of a heat pump. But if it's dark out and it's -40, you still need heat. So you have to have that heat source in place. So even though it's not very long, you do need that peak demand. And right now, I can say confidently that the best solution for that, and the only solution for that, is natural gas. And that's going to be the case for a long time, because even though there's improvements going on the air source heat pump side, you are not going to see air source heat pumps at -40. It's just, it will be many, many, many years before that happens. And so I believe that the hybrid technology, mixing heat pumps and gas, is a solution. Now, we're also going to talk about water source heat pumps, and Andy's going to talk about really in detail later. They avoid that problem and they can be a standalone without a gas backup. But there are lots of application considerations, cost considerations that go into that, and we need to have kind of all of these solutions in our toolkit and to apply. Okay, so I talked a little about the water source heat pump, and again, Andy's going to get into it. We have a couple of the most typical one would be the either horizontal or vertical loops, where you have plastic tubes drilled into the ground, circulate a fluid, and they become the heat source for an indoor water to air or water to water heat pump. And so they're using the heat in the ground as the source, but really what they're using is the ground as a battery. So you're putting heat into the ground in the summer and you're taking it out in the winter. Problem we have in our climate, though, is we are heating dominant. So if you think of that same battery, the battery is slowly decaying over time as the temperature range in the surrounding area around those boreholes or in the horizontal loops is decaying to the point that it gets outside the operating range. And there are solutions of that, and you got to think about a trickle charger. So you do have to find how you can economically and renewably put heat back into the ground if you're extracting too much. And there are ways to do that. And so one last slide that I wanted to talk about is carbon and the application of heat pumps right now and the forecasts that SaskPower has electrically. And I can tell you equivocally that if you put an air source heat pump in now, today, and even operating in hybrid mode, you'd actually emit more carbon emissions based on the emissions of SaskPower's grid today. Because, you know, natural gas is still a very effective way of delivering heat from a carbon point of view. Now, that's a moving target though. We can see that SaskPower's emissions are dropping dramatically over the next few years. And so where is the point where we're actually saving carbon? So I did a little bit of hand math, and with a COP of between 2 and 2.5, so not a very good heat pump, and one that's operating in cold weather, within about 3 to 5 years, you will actually be in a neutral position. So once we're beyond about 2028 and you're using even the poorest heat pump on the market, you will start to save money. So that's something to keep in mind, because it's not where we are now, it's where we're going. And in the solutions that come about, how we build now and make it get to our goals in the future. So I'm going to turn it over to Andy now, and he can talk a little bit more in depth on some of this. This is not on cost, but in 3 years, if you have an air source heat pump installed, it will generate no more carbon than gas. And then it will decline after that. But for a house, I think somebody said it's like $20,000. Yeah. I know, but I've been told that the market is. Yeah, it shouldn't be. It should be practically there. Be more than there. Yeah, but we have to make sure it's less than $5,000. Okay, so it should be like 7. Okay. So it takes, but I mean, both the marketplace is yours to better supply. So I think we just use it as well. So a heat pump, I can get close to the mic. Yes, you run a heat pump both in heating and cooling mode. And my position is that you should put the heat pump in now and just not use it in heating mode until 3 years from now, 5 years from now. Yeah, because I mean, almost every house that's built today has air conditioning in it. So you could spend a little bit, a small increment, and go up, so you're not paying the whole thing. And then because it's using more carbon now, don't have it in heating mode. As soon as the carbon intensity on the grid goes down, you can turn it on, or if you put solar panels on. But
good afternoon, everybody. Thank you, Tom, for a very good introduction about the heat pump. And I see that lots of people have questions about it. We need to do a little bit of the clarification what's going on. Okay. My name is Andy. I'm a faculty member here at the University of China. Basically, my talk today, I'm going to talk, just to echo whatever Tom talked about, is a heat pump for the cold climate. Okay. Before we get into the details of the heat pump, we need to look into the climate zone in Canada, right? So this basically Canada have about let's say 6 climate zone. We have zone 4, 5, 6, 7A, 7B, and also 8. Number 4 basically highlighted the very small corner around Victoria area, the warmest area, compared to number 8 is the coldest, right? In Regina, we situated at the zone number 7A, which is we define by using the term called HDD. Okay? And the HDD, based on just the number, it's basically about 5,000 to 6,000 HDD number. That is considered as a very cold climate as well. So the HDD is basically stands for the heating degree day. Is a measurement to quantify how much energy we need to heat the building. So basically, the HDD have the 2 components. One is how many days that we have the very low temperature compared to the standard temperature, which is 18 degrees. This is the 18 degrees C is where the heating starts kicking, right? So if we have a very long time, very long, many days to do the heating, the HDD will be all increased. Yeah. So in Regina, of course, we have a very cold climate. Okay? Looking into the temperature in Regina, basically this is for the average temperature in the city of Regina, ranging from January the 1st, which is the one on the left-hand side, to the basically the December 31st. Okay? If you look into the curve, basically we have a very long period that have very low temperature compared to the 18-degree mark. Okay? So that's been we have a very long time to do the heating each time of the year, basically about 7 or 8 months to do the heating. So because of the long period like this, in order to find a very good solution for the heating is really matter for us. Right? Of course, this is the very general information talking about a series of energy resources that we can use. We can use conventional energy resources, such as natural gas. We can use renewable energy, which is we try to go into that at the moment. In Saskatchewan, if you look into the map, it's a clean energy distribution resources throughout Canada, basically Regina or Saskatchewan. You have a very abundance of the solar energy, and also you look into the one on the left-hand side, we also have the considerable of the geothermal energy as well. So we should make use of all these renewable energy for our own benefit. Okay. So heat pump is basically one of the techniques, the possible or the I would say the practical solution of the technique that we can use to extract the renewable energy from the ground. Okay, and by using the heat pump. As Tom mentioned earlier, basically this diagram shows the 4 main component of the heat pump. It's nothing but refrigeration cycle. Okay, we use refrigerator at home, the same thing. We just move it forward, backward, in order to create the heat, or we say to transfer the heat from the, I would say, the low temperature environment here. Okay, it could be 0 degrees Celsius. Move this particular heat and provide to the heating space. And heating space could be 20 degrees, 25 degrees. So this is, to me, is basically move the free heat, I put it that way, from the ground and use in the heating facility. The one that we use to drive the whole system here is the compressor. You need to add some energy to make it work. Okay? So the very good concept of the heat pump is that, just like Tom mentioned, we need to provide only small amount of the power to run the compressor, but we can make the big chunk of the heat to supply to the heating facilities. Okay? So basically, if we look into the performance of the heat pump, we usually call coefficient of performance, or the COP. It's different from efficiency of the burning. It's different from the efficiency of the electric heater. This is the COP defined as whatever heat that we supply to the heating facility to the power that we input into the system. So that's why the COP always have to be greater than 1, because we supply only small amount of the energy to move the big heat to the facility. Example of the heat pump, COP, for example, if you have the heat pumps with a COP of 3, that means we need only, for example, 10 kilowatt of the power to run the compressor so that we can move 30 kilowatt of heat. That is basically the win-win situation. Just in my analogy, is basically getting 3 birds with 1 stone. Okay. This is the basic comparison between heat pump and also the conventional heater. I created this particular table to base on just one heating requirement on this left-hand side. Let's say we're just going to heat the house or the facility based on 120,000 BTU per hour, or about 3 tons of the heating. Okay? This is the baseline we have. If you use natural gas, 90% efficiency, we need to basically get energy from natural gas equal to 133,000. That is the energy we need from natural gas. Okay. The same number basically apply to the electric heater as well. If we use 90% electric efficiency, we use basically about 133,000 per hour to heat the house based on this particular requirement. But if we use heat pump, the COP of 4, okay, we need only the power that's supplied into the compressor, only 30,000 kV. So that we can move this much of the heat 120. So this basically can show that by using heat pump, okay, we have very good potential to save a lot of energy, okay, and the exchange. The performance of the heat pump also vary with several key factors. One of the factors is, of course, the type of the refrigerant we use. We can use 1R34A, which is the refrigerant that we use in your refrigerator at home. Same thing. Okay? Or you can use R410A, which is the typical refrigerant we use in the commercial heat pump. Another key feature is the temperature of the heat source. Okay, as a mentioned, you can basically move from that heat from the source, heat source with different temperature. And basically, the higher the heat source temperature, the greater the performance. So I basically put together just the basic concept of the 2 mode comparison. The very first one here is the heat pump that runs with the temperature of the heat source of 10 degrees C. Okay. This particular heat pump, they can provide you with the COP equal to 5. That's means you can produce a heat transfer 5 times based on the energy that you put into the compressor. So based on the COP of 5, we require the compressor require only 0.7 kilowatt per ton of heat value that you would like to move. If we lower that the temperature of the heat source to -30, the COP will start to drop right away to 2.3. So that means we need to spend about 1.5 kilowatt to move 1 ton of heat. Okay, that is the very fair comparison. So what I'm saying here is using the heat pump at the right temperature is a key as well. Okay. Now let's look into the heat source or the heat pump that in this particular case could be air, outdoor air, or could be the ground temperature. Okay. For the air, this particular plot I already showed earlier, the air temperature can go down to -20 degrees C. So that is a situation where the heat pump doesn't work very well because it's too low temperature. So how about the ground temperature? The ground temperature basically is temperature varying with the depth under the ground, under the surface of the ground. So I did a little bit of simulation and looking into the change of the temperature with the depth under the ground. Okay, so when you see the very top portion very close to the surface, about 1 to 2 meters, the temperature vary a lot during the year, in the summertime and the winter time. So it fluctuates with the air temperature. But if you look further down to about 5 meters plus, so the temperature is quite stable. Nothing changed with the weather. Even in the winter time, we could have about 5 degrees under that. Okay, so that's the key that we can make use of the temperature or the ground temperature to facilitate the heat pump as well. Okay. Now I did a little bit of a comparison between the different type of heat pump that we have air source, we take the heat from the outside air, or we take the heat from under the ground. Okay, so the very first one is when we use the air source, because of the fluctuation of the temperature, the air source can work very well during the April or very early fall. Okay, but because of the low temperature during January and March, and also towards the end of the year, it's not going to work because of the low temperature. Okay. About ground source heat pump, we have two different categories. The first one is horizontal loop. The horizontal loop basically you are buried under the ground, just 1 or 2 meters. So that particular range, you can see that you still have a big variation of temperature. Okay. So even though you use ground source heat pump, by using horizontal loop, sometimes it doesn't work because the temperature variation quite great. So it's going to work very well, of course, in the very early fall season, but the rest, because the temperature can go down very far below the 0 degree as well. So it's not going to work very well in deep winter time. If we use the ground source heat pump, another one we call vertical loop, we dig very low under the ground, about 5 meters below. It could range from 5 meters to about 60 meters. Because of that range, the temperature of the ground is quite stable. Okay, that means that work in favor of our ground source heat pump. Heat pump can always work all the time. Okay, so that's one of the things that I would like to mention here. By using ground source heat pump, the configuration also matters as well. Looking at this is the cost comparison. Just to pick the case of one household. By using the two systems, one is the natural gas, another ground source heat pump. The natural gas consumes quite a bit of the energy, so the operating cost will be quite high. For example, $130 per month. Okay, this is used as the comparison only. Do not use it as a fixed number. But by using heat pump, because of the COP of the heat pump itself, the operating cost will be quite low compared to the natural gas. Okay, so it can go down to about 30 degrees below what you use for natural gas. The capital cost, however, the natural gas burning is low. Okay, the capital cost of the ground source heat pump is quite high. That is something that prevents people from applying because we have to start building it up before we get the capitalize everything. It takes so long time, right? So that's one of the things that you might have to keep in mind about the use of the ground source heat pump. One of the costs that is huge for the ground source heat pump basically is the ground source loop itself, right? The heat pump unit is cheap, it's just like refrigerator code, but you need to link it back to the ground. So that you need a lot of heat exchanger, needs a lot of piping going on. And that, as is shown in this particular figure, there's a huge number of boreholes that you have to drill under the ground to make it happen. I do just a rough calculation and say, well, let's say if 120 heating supply we need in terms of the kilowatt, you're probably going to need about 81 borehole in order to make that happen. Yeah, and the footprint could be 63 by 63 meters. The depth could be 50 meters. So I'm talking about the reality at the moment. It's this particular portion is prevent us from using the heat pump effectively. So in order to lower the cost, what can we do? We can reduce the footprint by either design the entire system by make sure that we have a very good balance. Sometimes you have to put the heat under the ground during the summertime before we take the heat out in the winter time. So we might have to do some of that as well. Or you combine the heat recovery unit in order to take the waste heat from somewhere and use it as the backup heat instead of using 100% ground source, right? Or you may basically look into the thermal storage. For instance, we have a lot of sun energy. What happens if we try to capture that sun and put under the ground as well, become part of the thermal energy storage. And that is basically something that we have tried to increase the energy density of the ground so that it works more effectively. Okay? So that's something we can think about. So in conclusion, the ground source heat pump system can be used as an alternative to the conventional natural gas burning. The vertical ground source system is more applicable in the cold climate because it's cold down very deep. Ground source typically require lower operating costs, but the big capital costs, right? The improvement can be made to the system. And it's up to us to try to make it happen, to make it more competitive. And also in order to reduce the cost of the ground source heat pump, basically we try to reduce the footprint and reduce the strain. Okay. The last page, I just put it up the question that Tom would like to basically make some of the question for everybody, just try to see what's going on there and what should we do, and put some of the question for the research activity and to improve the entire system as well. Okay, so that's my talk about.
All right, we are running very late. Go ahead, one question.
Yes.
So I'm looking for buildings that are extremely out of bounds, for example, water. They're maybe 10 to 1 meeting. What is the best strategy for avoiding freezing?
One of the requirements when you're looking into the design of the piping under the ground, we have to have proper separation between, I would say, the borehole, so that they allow time to let the temperature of the ground balance out. But again, the best way is try to find a source that you can balance the heating and the cooling, so that that particular space can shrink down. So basically, you're not going to use too much of the space in that particular case.
So you're all very nice. Yeah.
All right, really good. Thank you so much.
Thank you.
Okay, our next speaker is Stu from the Regina and Region Home Builders Association. So that's going to be very good.
So we'll see.
Don't say that.
Well, okay, well, we're getting this set up. I'll kind of start my introduction because again, as you say, we're a little bit short on time here. So thank you to the faculty for having me out to speak today. Yes, on housing, yeah. Thank you for having me out to speak today to the group. We've been able to actually, I'm surprised as many people have remained as we're getting close to the end. So hopefully I can find a little bit of entertainment value here. So just as this is coming up, you know, what to me really made me think about what I've observed so far, you know, in the big picture is always made up of little details. And, you know, this last presentation is a good example of that. And so I'm going to talk a little bit about home ownership and home buying and you know, how that fits into decarbonization. I remember Greg saying, yeah, I'll stay right here. About, you know, the big challenge being retrofits and how do we move the market in that area. So as I started to think about this presentation, I went to my new mentor, ChatGPT, and asked it 5 questions. Who attends decarbonization seminars? Well, it's people like us in the room, right? We already have a stake in this at some level. Maybe, you know, maybe we're working for a government agency, maybe it's part of our work, but there's probably a more direct economic line between us and this subject matter. So who doesn't come to these type of seminars? Well, people with a lack of knowledge, people not interested. And for most people, we have so many more immediate priorities than this conversation today. So I asked the next question was, you know, do home buyers even care about gas emissions from their homes? And chatbot said, likely most of them do. In fact, some of them are willing to pay a premium to decarbonization. So why don't they? Because most home buyers, homeowners who are looking at retrofits see these things as prohibitively expensive. So the most important question I asked chatbot was, you know, what would it take to get homeowners to retrofit their homes to net zero energy really right now and not wait for the codes and all these other processes to come together. And chatbot was really clear on this. Incentives and subsidies offered, and explaining the process and the potential benefits. And so what got me thinking about that is, I think most professors looking at chatbot kind of rated chatbot as a C+ student at best. And if a C+ student can figure this out, so can we, because it is that simple. What I'm arguing today is that this is basically a marketing issue and a financing issue, because as you've heard through the day, the technology is already there. It's how we pay for it and how do we motivate people to make a different decision. So homeowners, they're pretty much almost there. You can find lots of different polls and surveys out in the market. Here's happen to be two of them. People are ranking energy efficiency as very high or somewhat high when they're making remodeling, buying a new home or buying an existing home. Avid Ratings, who a couple of years ago, they're doing another one. They've actually completed the 2022 one. That's just coming out. Rate energy efficiency, in the top 3 categories of what was important to them. So the consumer is pretty much there. When asked where would we spend the extra money, 16% of them said they would put it into energy efficiency. That's actually moved up a lot over the last decade that they've been doing this work. Having said that, it's still half of going into interior finishes. And let's, when asked, where would you spend the extra money on? About, 86% that somewhere between $3,000 and $10,000 was what they'd be willing to invest in additional energy efficiency. So let's start out with the premise that if building a net zero ready energy home, the home to code cost exactly the same, every home would be built to that right now. Because why wouldn't you? There'd be nothing but benefit and there'd be no downsides to it. But in today's environment, and I'm using an example of about a 1,500 square foot single family home, you're going to pay about $30,000 premium to get that to net zero energy ready. Good news is it's about $100,000 less than it was a decade ago. And as the energy step codes start to come into place, that is going to add costs, but it's going to start to lower that gap. And in fact, today, you can build that home to net zero energy right now for the same cost as to build to code. But there are trade-offs. And that's the challenge, is the trade-offs. Because this is the dream of home ownership. It's not just owning a home, but it's all the things that go into a home. Today, more than ever before, the amenities and the features that we can put into those homes are second to none. And so every home buyer, every homeowner, when making a renovation decision, has to balance off these trade-offs. And they're hard. Let me just use this as an example. This is from the towns on the southeast side of the city. A home over, these homes over here on the left hand of the screen, they're single detached. They're kind of on a zero lot line, so they're absolutely maximizing the land space on there. And then the picture on the right are those homes, but on the south end of the street there is a set of duplexes that are going up. The square footage living spaces are about exactly the same. Same builder, by the way. They're all going to have double front garages and very similar finishings. So the only differences between these homes are going to be is whether you got to share a wall with a neighbor or not, right? And that's about a $50,000 premium to have that decision between whether I want to have my neighbor as a partial homeowner with me, or if I've got my own space. And so that's competing every day against those decisions around decarbonizing and making those investments in our homes. And, making hard decisions is difficult for humans. It involves trade-offs. So sacrificing one desirable outcome for another. And, you know, when we apply our own personal values, our beliefs and emotions, again, it's hard to remain objective through that process. So let's talk about climate change communications for a while. Tends to be like we see in discussions like today, very scientific, lots of public talks, lectures, you know, media interviews, social media, public campaigns. I Googled on Google Images, I put in climate change, and these are the first 4 pictures that come up, you know, the earth on fire, all the macro impacts of our decision. And so what you're starting to see in the literature there today is what researchers are calling, you know, climate change reactants. And that is actually starting to push me back from the communications that are happening in this subject. So that really got me thinking about climate change as a brand. So as a brand, the early adopters and the innovators, they're there, right? Those are the people who are making these decisions right now. And you know, that is certainly moving and moving forward. Having said that, the vast majority of people, when making home buying and renovation decisions, they haven't moved far enough down that change that they're going to make those type of investments that really need to happen to hit the goals that we have seen out there today. So, how do we get homeowners and home buyers to take action? Well, what I would suggest today is we need public and consumer education focused on the benefits of net zero homes and retrofits. We need municipal, provincial, federal, and crown utility incentives, and we need to leverage financial tools like mortgages and home ownership. And I'll dig a little bit deeper into those here. So, you know, the benefits of investing in net zero energy homes. So as I've talked in the past to builders right here in Regina who build net zero energy homes today, and I've talked to them in the province and actually right across the country, what's interesting is what they have in common. They don't talk to their clients about climate change, and they don't talk to them about decarbonization. They talk about a better lived experience, about how that home is going to have, you know, better temperature control, that you can regulate each room and make it much, much more comfortable to your liking. How drafts are essentially eliminated. And air quality, this is a really big one. How allergens and outdoor air pollution, you know, essentially disappears. And how quiet the homes are. So no more traffic, no more lawnmowers, no more listening to the your neighbor's barking dog. And the return on investment. This is an area where we really need to invest a lot more time and effort in showing home buyers and homeowners those returns on investment. So there's the obvious one, immediate monthly reduction as utility bills and how they stay low, and how it protects you from future increases in energy prices over the past few years. And that can really be a big deal. But here's one example of a study I found from Zillow. They looked at 3 million home sales over a 2-year period and discovered the average price premium on those homes for these typical features placed in the home at the resale of the home and how it actually sold those homes faster. So I just use the example of a $500,000 home. If you had all those features in your home and you sold it for 4.65% more, there's $23,000 right there on the resale of that home. And if it's sold for 57 days faster on your average mortgage, where current interest rates are at, you get about another $5,000 in savings there. So remember, it's about $30,000 extra investment. Well, there's 28,000 of it right there, all at the same time as doing our part to, you know, on the decarbonization. So let's talk about the government and utilities needs to invest in the transition of existing housing stock, and they have lots of programs. But I could spend I can usually do an hour presentation on the anecdotal examples we see when governments make very direct investments in public policy changes around housing versus the other type of tools that they put in place. And that's because, you know, a fundamental insight at the heart of economics is that people respond to incentives. And that's a big part of the key here. So I imagine, or I fantasize, what would be the incentive that would not make us wait till 2032 till the codes are fully in place, that would move people today to make those type of changes in their decisions. Well, we already have the Greener Grant Program from the federal government, which has been pretty successful, by the way. There's capacity issues out there, but that applies to retrofits. It can be gained actually to apply to new housing with a little bit of creativity. But imagine if the provincial government invested 1.5% of the PST towards this particular change. Imagine if Sask Power, I didn't pick on Sask Energy, but I'll throw them in there as well, did the calculations on the savings in energy that they will have to produce in the future, and allocated a portion of that to this type of incentive. Imagine if the city of Regina, and I see Kelton back there in the corner from Building Standards, and we pick on him a little. Imagine if they waived all permit fees for net zero energy retro homes or retrofits. There's another $2,000. So somewhere in between this crazy idea, we've got about $10,000 to $17,000 worth of incentives that the public would certainly take advantage of. So why would using the example of the province, why would they want to take such an action here? Well, if you look at the provincial government's growth plan, the growth plan is to have 1.4 million people living here by 2032. And so according to the Real Estate Association, we got to build about another 95,000 housing units. So if the average home uses 100, new home uses 100 gigajoules of energy, and a net zero energy ready home uses only 42. If all those homes were single attached, and of course you could divide this up in many ways, but if all of those homes were single attached homes built brand new, you know, it's going to require about 10.1 billion kilowatts from now to 2032 to power those homes if they're not built to where the codes are by the time we hit to tier 4. So again, we don't know the accuracy of these calculations. We try to do something crazy on these numbers, looking at Sask Power's annual report. And so it looked to us like it's about 11 cents per kilowatt hour, you know, to energize those new homes. So for Sask Power, they're going to have to, over that period of time, from now to 2032, are going to have to invest about $1.2 billion in that energy capacity as an expense. So if you kicked in 500 million towards and sent all of those houses at $5,000 a home to make that change, Sask Power would end up with a net gain of $618 million. The approximate PST on those homes will be about $2.4 billion. So again, if the provincial government kicked in 1.5% of that back, based on that amounts, again, they'd still be the net good for a $1.8 billion increase in PST. And here's the real kicker. In a province that often has the optics of being slow adapters to decarbonization, this would be the most progressive incentive program, not only in Canada, most likely North America, you know, potentially even the world. Now, sorry, I'm going the wrong way on the slide here. Now, what's the role of financing in decarbonization? Again, imagine if we could get CMHC, the Bank of Canada, the federal government to develop a program that just reduced the interest that's being charged on a home by 0.5%. They built or retrofitted to net zero energy right now. So again, just use a simple example of a $500,000 home or a $500,000 home with the extra $30,000 to hit net zero ready in there. And you just reduce that interest rate by 0.5%. You know what? The interest savings over that home would be about $22,000. Your payment would go up by $7 a month, and you'd have a net zero energy ready home today. And the demographics really work well. Generation Z and millennials, they are the future now of home buying. They are the future of home building. They have a very high interest in climate change, decarbonization, and also home ownership. So those pieces come together to make some really good motivation there. But here's the rub. In our country, we have made it exceptionally difficult for young people and young families to access home ownership anymore, and to achieve that. In fact, recent polls show 63% of Canadians who don't own a home are actually giving up on the idea of home ownership, even though 76% of them feel that owning a home is the best investment a person can make. And you take Regina, last year, over 50% of new housing starts were for purpose rental. And actually so far this year in the first quarter, that number is closer to 90%. So we've really shifted public policy to the rental market. Here's the challenge around decarbonization. As a homeowner, as a home buyer, whether we can motivate you or not, you've got a direct stake in investing capital into the quality of your home and decisions around that. As a consumer group, renters have very little power, market power to that direction. And we also leave a lot of money on the table for renters when we have public policy down this path that works against them making those investments into the things we've been talking about today. And I'll just again use an example of approximately a $500,000 home that's built brand new with $30,000 extra invested into net zero energy. Let's say you bought a resale home for $375,000, did that $70,000 renovation, so you get that beautiful kitchen, but tucked away $30,000 to again make those energy improvements. Or in Regina, you got a townhouse, a decent one would be about $1,700 a month. Well, over a 25-year period, the difference between home ownership and renting during that period is about $500,000 in net worth. In fact, there was just a recent report that just came out that calculated that millennials who stay renters the rest of their lives will have to save 50% more than millennial homeowners in their retirement programs. Again, that's all money competing against decarbonization and making other investments in these areas. So kind of bringing this up as quickly as I can to conclude this is my thought on what needs to occur. Communication, marketing, and retrofits and building new needs to focus much more on direct benefits to homeowners. All level of government needs to invest real dollars in incentivizing this transition. We need to leverage the fiscal capacity of homeowners to invest in decarbonization and make it easier and cheaper to finance and get approved when people are making the right public decisions to invest in decarbonization. And yeah, that's what I have to say. I'd glad to take any questions, although I know time is running.
It's fantastic, but I do need to limit questions. We have one question. I think you answered everybody,
Okay,
but it was brilliant. I really appreciate it. Really good. Okay. So our last speakers for the day are Alicia and Kevin. There's Kevin. This is going to be complicated because Kevin is in Ottawa? In Toronto. Okay, so Alicia has all the slides. Let me see if I can bring them up. Wow.
This is the mic.
Yeah, that's the one. Okay, which slide am I looking for? Efficiency, I remember.
Just present it. Yep.
Which one?
This
This one. Oh, this one?
one. Also helps.
Okay. All right,
Good to go.
good to go.
Okay, cool. Everyone can hear me? Yeah, okay. Kevin, can you hear us? Oh, we can't hear Kevin.
We could just a bit ago.
We could, yeah.
Is he muted?
No, not muted.
Sorry, is that better?
Okay, there we go.
Okay, thank you very much. All right, and in the spirit of moving quickly, I'll just do my best. And so first off, my name is Kevin Lockhart, Research Manager at Efficiency Canada, and along with Alyssa, we'll be discussing many of the ways that we can build on the presentations, incentivizing heat pumps and more generally net zero energy ready buildings, all through Canada's changing policy framework. And it really is changing. We're entering a new era of high performance buildings. By the end of 2024, Canada will have a much different building codes landscape. The net zero energy ready codes will have been adopted by each province. Net zero emissions codes will be available to provinces for adoption. And also the alterations to existing buildings to regulate retrofit activity in existing buildings will also be available for adoption. Thank you, Alyssa.
Sorry, where are we at, Kevin?
That's perfect. I was going to go over the Efficiency Canada slide, but I think we're good here. So what are the signals for policy? What's coming down the pipe? So first off, our building sector accounts for about a quarter of Canada's total final energy use. And when including electricity use, about 18% of greenhouse gas emissions. So this places buildings and the energy they consume as a critical part of reaching the climate goals of every level of government. And the 2020 Net Zero Energy Ready codes, the Net Zero Emissions Code, and the AEB all represent that exciting shift in how we view building codes, and also how the building sector can help use those codes to cut waste, energy waste, and emissions. And it's Canada's municipalities, and in particular in code enforcement and compliance, that will be tasked with being on the front lines of not just extreme weather, but also implementing these codes. Municipalities in particular, as we drill down through international, national, and provincial commitments, again, are on those front lines. So first we have the Pan-Canadian framework, I'm sure everybody's familiar with, but it signaled a shift in building codes from those designed to meet a minimum acceptable standard towards those that use tiers or steps to reach a stretch goal, much like the BC Energy Subcode. This also saw most provinces and territories commit to a net zero energy ready standard by 2030. We have the Canada Free Trade Act, which the RCT, which saw provinces and territories commit to implementing the 2020 national codes within 2 years of their publication. We also have the 2020 mandate letters, and they were quite important, as before those mandate letters, there was no ministerial oversight of building code development and implementation. There's now two ministers responsible for such with mandates to see the successful implementation of the 2020 codes. We also have international work or commitments like the IEA Net Zero by 2050 roadmap for the global energy sector, as well as the latest IPCC report. Both of these emphasize a renewed urgency to decarbonize the building sector. Going back to the mandate letters, we can also see a tie-in, given that mandate, with things like the National Green Building Strategy, which will be coming up this summer, It places a renewed focus on building standards and policies needed to reach net zero. So a lot of those supportive policies mentioned in previous presentations. And the mandate letters led to other things like the Net Zero Building Code Acceleration Fund. This was a $180 million fund available to provinces and municipalities, as well as private or nonprofit organizations looking to accelerate upper tier code adoption. And it's not just necessarily a top-down priority to have net zero energy ready codes. So in 2021, Efficiency Canada conducted polling with Abacus data. And in that polling, we found widespread support for net zero buildings. And the support was again amongst all provinces and saw approximately 70% of Canadians support or strongly support net zero energy ready building codes. So it's clear that going back to Stu's slide, that Canadians do recognize that the benefits of a more comfortable home with fewer drafts, better indoor air quality, as well as protection from increased energy prices. Sorry, thank you, Alyssa. Yeah, that's one. And so just want to talk a little bit about tiered codes and how they differ from conventional codes. So tiered codes offer a framework for increasing the energy efficiency of new buildings at each tier. This stepped approach starts with the base tier, tier 1, that's roughly equivalent to NECB 2017 or the National Building Code 2015, and moves upward through the tiers to the net zero energy rating standard. The key benefits of the tiered codes is that it offers a roadmap for where we're going. It also helps foster confidence in the market, and that confidence will allow industry, builders, developers, as well as individuals invest for the former in their business processes, and in the latter in their workforce and career potential. Tiered codes help bring together in that roadmap, that long-term roadmap, help coalesce things like technical leadership, education, incentives, and programs based on having a long-term anchor around which they can develop a strategy. Tiered codes also provide a significant degree of flexibility for local governments. And local governments, given their other capacities like responsibilities for land use as well as compliance, building code compliance, helps or places municipalities in a good spot in order to shorten the runway to the net zero energy rate standard. Thank you, Alyssa. And so in terms of next codes, the net zero emissions code. So the net zero emissions code was announced in late 2021. The federal government committed to develop a net zero emissions code by the end of 2024. This was a big shift in building code policy, but it also gave just 2 years to prepare for a significant policy change in terms of how to develop that code. And in the development of that code, there's a range of new issues and that need to be resolved, as well as terminology that needs to be defined. It consists of a rethink of the fuels we use to heat our buildings, as we've seen in previous presentations, as well as the materials and components that we use to construct them. It also leads to new considerations about how the net zero emissions code will interact with other codes like the net zero energy ready code. Sorry, that's the next slide. And why the need for a net zero emissions code if we have the net zero energy ready standard code or net zero energy ready code? And it's really because, excuse me, in the past, emissions from construction have been addressed through that fairly narrow definition of energy efficiency. And this definition didn't account for things like the fuel used to heat our buildings or the implications of material choices. In terms of where we're going with the end goal of the net zero energy rating standard within the 2020 model codes, we take a step forward. But despite that step forward, as the BC Energy subcode has shown, tiered codes alone, even at the highest tiers, can't guarantee reductions in a building's operational or embodied emissions. And in part, this comes down to fuel choices and highlights the fuel agnostic approach that the building code has taken in the past. As this code is being developed, it will require an objective within the model codes, as all building code requirements must be tied to an objective. And the addition of that greenhouse gas emissions objective is now being added. Next slide, please. And And so this slide is really intended to highlight where we're at in terms of the development of that code. We're in the very early stages with both policy and technical components being developed in a somewhat unique concurrent manner. And work is also underway, as I mentioned, to include that emissions objective. We're also dealing with some of the fundamental questions which we raised in our municipal guide for net zero emissions codes, but also within things like the public comment period, the consultation that was just held, wave one, I guess it was termed, for the net zero emissions code, and which just closed this past month. And we'll also see a second wave of call for comments in later this year that will look at very specific questions, some of which we're talking about in this presentation. I'd also like to highlight that due to the 24-month period under the Canadian Free Trade Agreement of adoption, some measures, including those, or particularly those for embodied carbon, won't see real action until 2032. So as the code is developed up until 2030, 2025 will focus on operational emissions and embodied emissions in 2030. With the 2-year adoption period, that puts us at close to 10 years. Next up, so the previous two codes deal with new construction. And really it's about getting to the point where new buildings are doing no harm in terms of energy, their energy use and their emissions. And then we also need to address existing buildings. In terms of how we've regulated existing buildings in the past, there's been a lack of harmonized requirements. This is recognized in the Pan-Canadian Framework and then later reiterated in the Canada Strengthened Climate Plan, A Healthy Environment and a Healthy Economy, in which there was a commitment by all provincial and territorial governments to develop and publish a new model code for alteration to existing buildings by 2025. So while standard building codes are expected to cut emissions from new construction, the remaining reductions come from addressing existing buildings. And the AB is considered to be a key component of that, and it'll drive performance of existing buildings at the time of alterations and achieve the provinces, territories, and our federal climate goals. It's also intended to fix the lack of a consistent regulatory approach for existing buildings and provide a consistent standard for retrofit activity. Thank you, Alyssa. The AB is based on the most recent National Building Code and NBC 2020 and the National Energy Code for Buildings, NECB 2020. And it's defined by 8 principles, 8 overarching principles. And these begin with closing the performance gap between new and existing buildings, as we heard earlier. In addition to closing the performance gap, there's an expectation of maintaining or increasing life safety, avoiding negative unintended consequences or unrealistic expectations. And I think the latter part of this point is quite important. The AEB, it will be limited. We've seen our retrofit rate set at about 1%. 1% of the building stock is retrofitted each year. To meet our national climate commitments, that retrofit rate has to increase to at least 2.5%, if not higher. The AB, and we'll look at the triggers in a moment, is voluntarily triggered. So it will be difficult to see those energy efficiency gains and emissions reductions from a voluntary code. Next up, still on the previous slide. Next up, we have the building cannot be left in an unsafe state, and that all regulatory measures should be reasonable, pragmatic, and effective. The AB, importantly, will have to be flexible, and so it has to balance the stringency of a code requirement that's voluntary triggered with the expectations of the owner or the abilities of the building owner to resource those retrofits. This is in part to avoid either those retrofits being put off or being served in the underground economy. It also needs to be flexible in order to recognize heritage elements and the regulatory measures and voluntary programs. And so this is really looking at other regulatory measures at other levels of government, but also voluntary programs. Each of these should complement each other. All right, and next slide, please. Oh, I think we might be a little bit one slide ahead, I think, just on triggers. There we are. Yeah. Oh, sorry, wrong direction. That's okay. So as mentioned, the AAB is triggered by voluntary action of the owner, and it also applies to the portion of the building, only that portion of the building that is being altered, or any new additions to the building. So this begs the question of how code requirements triggered voluntarily to alter, renovate, add, or change or repair the existing building can be used to drive higher levels of retrofit activity, as well as balancing the concerns of project proponents. And these might be related to cost, scope, or the complexity of the planned project. Now, costs are one of those items that many might expect to be considered a trigger. However, they aren't. And this is largely based on the experiences of the rollout of Vancouver's bylaw 1098, which regulated retrofit activity. And in that, they saw that those triggers could be gained or taken advantage of, and project costs could be tailored as such to fall below that threshold. It also highlights the significant variation in costs across markets in Canada, as well as the potential to drive retrofit activity underground once again. Now, codes can only go so far. They do need to find new ways to create incentives and encourage things like heat pumps, which can take advantage of a clean grid. And my colleague Alyssa will now step into those.
Excuse me, thanks, Kevin. All right, I'm going to be balancing two screens because these are where my notes are, just in case, so don't mind me. All right, so Kevin spoke to us about building codes and saving energy in our buildings. I'm going to talk about energy efficiency program outcome data that we have, as well as some policy tools that other jurisdictions in Canada are using to save energy in buildings. Let's go. All right, so we'll start off with very simple, why energy efficiency? Why is this important to decarbonizing buildings? Well, we know that the federal government has committed to a net zero electricity grid come 2035. What that means is we're going to be seeing increased electricity demand, and energy efficiency is a utility planning energy resource. So we can see this as energy is just waiting to be found, essentially. With this growing electricity demand, energy efficiency can manage peak demands and help to avoid possible grid constraints. As Kevin was talking about with codes, this is an objective-based strategy. And so there's 5 objectives that these codes are looking to improve upon. Not included in there are emissions and energy efficiency standards. And so there are a lot of processes, products, technologies that fall outside of the building codes that can still help us get buildings onto that path to net zero. Those things are, like we've talked about all today, heat pumps, highly efficient appliances and equipment, amongst other things as well, but that being one of them for sure. All right, so I'm going to show you a few graphs here. These graphs, they're comparing a selection of Canadian provinces and American states. And this is from a larger comparison report that we released a month ago. This is using data from our most recent American and Canadian energy efficiency scorecard. So this is based on programs that were run in 2021. So electricity savings targets here. This is showing you what some states and some provinces have aimed to save per year. And so we can see that New York is leading the pack here at 2%. And it's quite a significant lead. The highest ranking Canadian jurisdiction is Nova Scotia at just about 1%. Next, if we move to, we're moving from electricity savings targets into realized savings programs. And this is for energy efficiency programs. Again, that were run in 2021 annual incremental savings. And so if we look at this, again, we see that American states are leading the charge here. They again, California is up top, New York as well, Nova Scotia being again the first ranked province. But again, it being about double, California saving about double or more than double of what Nova Scotia saving there. Now, if we hop over to natural gas and fossil fuels, let's try this again. Fossil fuel savings includes natural gas and non-regulated fuels. This is a little bit more of a balance that we see amongst Canadian jurisdictions and American jurisdictions in the kind of in and amongst the top 10. Though American jurisdictions are still kind of leading the metric. We see that Quebec ranks quite high at 0.74%, and then Massachusetts is 0.93%. Saskatchewan, you can see here in the red as well. All right, so big question is why? What are these leading jurisdictions doing to save this amount of energy through energy efficiency programs? One of the main ones that we see in the US is that there are mandatory energy efficiency savings targets amongst many of these leading jurisdictions. So these are called energy efficiency resource standards. And what they are is essentially long-term mandatory targets that are sufficiently funded. Many of these leading states also choose to target all cost-effective energy efficiency available. And this is not something that any province fully does here in Canada. On top of the energy savings targets, we're actually also seeing that some jurisdictions are spending targets within their energy savings and demand side management plan. So if we look at Nova Scotia's most recent demand side management plan, they have targeted 20% of their total budget to be spent on low-income and Indigenous community programs. This is to ensure a just transition as kind of we move through the process. Okay, so there are a variety of energy efficiency programs, ways to save money. Sometimes they are specific to the context of the province in which they are run. Here's just some examples of kind of what different jurisdictions are doing. We see in Quebec that their electricity and their natural gas utilities have partnered to create a dual energy heating program. So this is a case where the electricity, the heating is largely fueled by electricity, but the natural gas utility acts as an auxiliary service and auxiliary fuel, so that when maybe heating is too expensive, when time of day calls for it, or maybe when there's extreme weather events, that natural gas can kick in and meet that need. We also see that there are pilot projects being done, a few of them around the country at the moment, where jurisdictions are looking to find what are the right technologies, what are the right strategies to scale a deep energy retrofit program. So I referenced one here in Fortis, BC, trying to figure out what works for that jurisdiction in particular in this country. Another thing that happens is an opportunity to crowdfund. So we see sometimes that provinces and the federal government partner to co-deliver a program and essentially enhance incentives. So a good example of this is Enbridge. They are the natural gas utility in Ontario, and they are currently co-delivering the federal Greener Homes program with the federal government through a program that already existed, the Home Energy Rebate Program. By doing this, they're able to enhance those incentives and offer more to those people that are applying for the rebate. So this could cover anything from insulation, windows, and as well as the electric heaters. Okay, so again, a little bit more data from our most recent scorecard. So important to building decarbonization, important to building decarbonization is ensuring that we have the people to do the work to complete all the work that needs to happen. And so here we show you the number, I will say on the left-hand side, we show you the number of home energy advisors per 10,000 households. And then on the right-hand side, on the commercial side of things, the number of certified energy managers per 100 large businesses. So these building professionals play a really key role in ensuring that we can roll out these energy efficiency programs and achieve energy savings. And things like the model codes, the building codes, and strong market signals add certainty to these professions and ensure their longevity. The more certainty we have about these roles, the more people will come into that space. All right, and just lastly here, one more thing that we see provinces doing, both provinces and municipalities are using home, excuse me, pardon me, are using home energy labels as well as mandatory disclosure on the commercial level. So for example, we see in Alberta, specifically in Calgary and Edmonton, there is an energy label program for households. What this does is these energy labels show where a house fits in terms of their energy use amongst other houses of their similar kind. So this can come into play when, let's say, a buyer is interested in a home. They can understand how energy efficient that home is, what upgrades might need to be done, or maybe what upgrades still need to be done, and what kind of money they could save coming from a different home. So essentially these are all different types of policy tools that are being used across the country. The stronger the policy, more energy we can save and continue to decarbonize our buildings. So that's everything we have for you today.
Questions for Alicia and Kevin? I think I have just there's a question. Good.
So
Okay.
today, when you think in terms of the scale of the grant, do they need to be bigger for retrofits? Like, what do you think for residential homes? Like, is $5,000 enough to get retrofit done, or do you need it to be tens of thousands?
Sure. Kevin, did you hear the question?
I heard about the scale of the grants and is it appropriate? Is that correct?
Wondering that is the scale of the incentive appropriate for and enough for what we're looking to do?
Mm-hmm. And I think again, Steve mentioned it earlier on, the Greener Homes grant in particular has been a little bit challenging. I think the important part of that is to recognize the challenges, recognize that we're fairly early in this process, and provide feedback on those challenges, and also as a consumer, are those $5,000 grants appropriate? I think once they're stacked with provincial, utility, and municipal grants, that they can, depending on where you are, they can be significant. But again, I think as a country, and Alyssa, I think your opinion on this would be great as well, that better coordinating our how we stack our incentives is one of the key barriers or key opportunities, depending on how you look at it.
No number, right? 50,000.
Accurate. I think that's one of the fundamental questions that we want to task whatever working group comes out of this, is that if there's some way that we can quantify what that is, because that's been a question that's been raised over many past number of months. Is it appropriate in our climate, in our economy, in what we're trying to do? So I think it's a great, outstanding question that needs some real work to give some guidance to all levels of government and the funding agencies.
Yeah. So if I can follow up to complicate that number a little bit, I think if we do look at the cost of or what the optimal incentives or what the optimal cost of a retrofit should be, we have to look more widely at the cost of ownership. So looking at a total cost of ownership and recognizing the longer payback periods for energy efficiency measures, but also looking at non-energy benefits. And so things like indoor air quality or resilience, adaptation, how do these play in? And I don't know, but I would suspect that we'll see that there's lots of room for incentives to increase to meet the I guess the challenges that different social and environmental challenges bring.
Okay, I think we're hitting 5 o'clock. I think we've tired everybody out. And I appreciate your tenacity in staying right to the end. I do apologize for some hiccups I had in terms of setup, but this is the first time. Please come to the next symposium. I'm sure I will do better. And with that, thank you so much. And I will be sending out an email to all the registrants, asking about, feedback, asking about participating in the working group, and connecting you to the next steps that we're going to take in this and the following symposium. So thank you again.